welcome Global Head of VR/AR Strategy from Unity Technologies, Tony Parisi.
Hello, welcome to Vision 2017. We've got an exciting 2 days ahead of us. If you were here at last year's Vision, you might remember it was mostly about gaming, because the game industry is always the first to jump on any hot new technology. Well, we now know that virtual, augmented, and mixed reality are impacting every aspect of how we work, play, and communicate. This year's Vision brings together creators, leaders, and innovators from across industries in a shared exploration, a conversation about what's possible with this awesome new technology. Now, I've been in immersive computing for some time now, a few more years than I'd shared to count. So that's why I'm so excited that this technology is finally, really, almost here. But we all know we have a long way to go before immersive experiences are an essential part of everyone's daily lives. I could talk to you more about this, but I'd actually like to introduce someone who's far more qualified. I've known the Unity founding team for a while now, and I've been so impressed by their focus and the commitment to their core mission. I've recently met the person at the helm, a visionary leader who is the ideal person to make this vision a reality. So I'd like you all to join me in welcoming to the stage Unity's CEO, John Riccitiello. Knock him dead, buddy.
Well, thanks, Tony. So look, we're all here because we're believers. And I firmly believe we're in the era where we're going to see the rise of an amazing industry in the world of VR, AR, and mixed reality. And I'd like to share with you a little bit of an analogy. I got backstage with Brendan O'Reilly, one of the founders of Oculus and maybe the guy that started the spark of all this thing. I was telling him that the way I see it, in the fullness of time, we're going to see the world of visual compute, AR and VR, develop a lot like the internet. Now, today, there's almost 4 billion people with access to the internet. Their access comes by way of PCs. It comes with a smartphone right up against the face. But this industry took about 20 years to develop and get to this massive, massive scale. It's much bigger than anybody ever thought. And I see a world with absolute clarity, a world that you might describe as visual compute, when we're interacting with entertainment experiences, we're interacting with data, we're interacting with our friends, we're interacting with travel, we're right in the middle of the Taj Mahal. And the metaphor that he gave me, and I thought was so apt, is that if you think of it this way, the first time we had a screen in our houses, and thank God none of us were born, was television, but that was like 15 feet away, 10 feet away. We then got PCs that were, 2 to 3 feet away. And now we've got phones in the right here. And we're now about to jump through the screen. It's been a steady progression to get closer and closer to the experience we're interacting with. And we are at the dawn of that age. And I firmly believe that we're going to see literally the biggest industry we've ever seen. It will rival the internet. It's not going to be something like the size of the game industry or the size of the music industry. It's going to be the size of everything. Now, a lot of you, slides are not working. That's what we said. I don't have tap shoes. There we go. We got slides. And a lot of you know Unity. And as a company, as Tony mentioned, we're very much a mission-driven company. We talk a lot about developers. We talk a lot about democratizing development. We talk about and do solve some of the hardest problems. And we work very hard to help developers be successful, whether they be in mobile or console or VR and AR. And one of the hardest problems that we spend a lot of time solving, okay, I think we've learned this isn't going to work on a regular basis, but one of the hardest problems we solve is write once and get all of these platforms. You don't have to take platform risk, and you don't have to port to dozens of platforms. We make it easier. Literally, there's 1,000 engineers writing core technology for Unity, and you can think of them as your R&D team, your engineering team, except it's probably a little bigger than your R&D or your your engineering team, and they're working for you day in and day out. In one area they're really focused on is the world of AR and VR. And these are our partners in AR and VR. And look at those companies: Google, Microsoft, Vive and Steam, Oculus, which is Facebook, Sony PlayStation, Samsung. These are some of the biggest companies in the world. And it's amazing all that they're doing. Now, I'd like to step aside for a quick analogy, though. Let's go back to the dawn of the game industry, or at least the console game industry, with the introduction of the Atari platform, and those of us can remember Pong. We then saw sort of a table stakes battle between Sega and Nintendo, and ultimately a battle between Nintendo, Microsoft, and Sony, all bringing hardware to the market. I would argue that these hardware companies created the opportunity for the industry to exist. But I would say it was companies like Ubisoft with Assassin's Creed, EA with Battlefield and FIFA, Activision with Call of Duty, Blizzard, other great companies that actually created the industry. These people create the opportunity, and I believe you all will create the industry. Now, I will tell you when we need to forward the slides, because I think we have a dead clicker here. But look, content's come a long way, an enormous way. The breadth of content gives me such an enormous amount of confidence about the future of our industry. I mean, look at some of this stuff. It is truly amazing, and what you're going to see coming in a few minutes is presentations from many content creators and innovators showing you the way. Now, a key observation on this slide is this. I'm going to go back to that analogy about the console industry. So a lot of us think it's sort of a foregone conclusion that the world of AR and VR is going to be led by behemoth companies. That the advantage, say, that a Disney has in owning Star Wars and owning Spider-Man is just, too hard to ignore. They're going to dominate. But that's not the way it's ever worked before, and I don't think that's the way it's going to work this time. So if you go back to that console war that I was talking about, Activision, Take-Two, Ubisoft, and Electronic Arts did not exist at the dawn of the console industry. They responded to the opportunity created by the hardware companies. Or let's look more recently at mobile. At the launch of the iPhone, Supercell didn't exist. Machine Zone didn't exist. King didn't exist. These companies responded to the opportunity, virtually bootstrapped. And I think you have that exact same opportunity today. Now, before you get too excited, and I know there's a lot of excitement to be that next generation company, I think we need to think for just a minute. Now, about a year and a half ago, I put this slide up. I called it the gap of disappointment. And what I was contrasting was my expectation for how the industry would develop versus the analyst forecasts. And the analyst forecasts were exuberant and super aggressive. And the point that I was trying to make is the hardware and software wasn't ready for prime time, and it wasn't going to take off like this. And that in the long term, I believed the industry, in fact, would exceed the opportunity that any of these analysts saw coming. The key point is, I think in long term, it develops like the internet. Go back to analyst forecast of 1999, 2000, the internet was going to be a sector in our economy. Damn it, it is the economy. And I think that's where we're going with visual compute. Now, the analysts, as clever as they were, they took this slide, lowered their forecast a little bit, and they called it, I think it was a trough of disillusionment. It sort of rhymes with a gap of disappointment. But here's a couple quick thoughts. Thought number one, if you know any analysts, pigeonhole them, show them the slide. It doesn't do us any favors to see forecasts we're not going to make. The second thing is, when they write about their trough, their gap, or whatever it is they're talking about, remind them of this as well. While they had forecast $5 billion in 2016, the industry achieved $2.5 billion in 2016 from a near zero start in 2015. That is stupendous. So measured on the wrong curve, it feels like the industry came up short. Can you think of many industries that went from a zero start to $2.5 billion in 1 year? That is absolutely staggering. And we should be super thankful that it's been that successful thus far. And the promise in front of us is huge. Now, one point that I put in here in terms of time frame, and I'm about to talk to you about time frame, is that at least in my vision of the world, the industry in its actual performance will cross the line of the analyst and exceed what the analysts are saying by the year 2023. And what I'd like to do now is talk to you about some of the precedent conditions that need to be true for this to happen. And I believe they're happening as we speak now. Now, the first point is price point. And in order for us to have a mass market, a truly global mass market, I think what we need to see is a price point under $1,000 for the CPU, the GPU, the head-mounted display, and the controllers. We're not there today. Yes, you can strap it to your PC or your phone and get there, but you can't get there all in. And I think it's an absolute requirement for us to hit a price point under $1,000, and I think it's a requirement to have a pathway down to a significantly lower price. That is in the works. I've seen it. I know what's going to happen. I'm not responsible for those price decisions, but I know that the leaders in this industry want to see this happen and will in fact make this happen. The second point that I'd point out is mobility. Now, what I picture is something that I think a lot of you picture. And it's not a head-mounted display with a big cable off the back of your head strapped to a 30-pound water-cooled tower PC. I picture a world where it's all on board. It's either in your head-mounted display, it may be a mobile phone strapped into your back pocket, but what you're going to get is the full kit. You're going to be mobile. It's not just a mobile device, but you, in fact, will be mobile. And whether it's AR and VR, you're going to be wandering around your house or whatever environment you're experiencing this amazing thing in, and you're going to feel safe, because if it's AR, you're going to see the stuff there, and if it's VR, we're going to see inside-out cameras bringing that world to you. Now, maybe your coffee table will be retextured as Mount Doom. I don't know. Whatever it is, you're going to know where it is, and you'll be trust it well enough that if you see a chair, you will in fact be able to sit in it. So criteria one, under $1,000. Criteria two, truly mobile. And the third criteria that I think we need to get to is price point. Now, excuse me, price point, wake up. Content. And in the world of content, I want to make a simple point. For you to make the investments that are required to dream the big dream, to get the VC dollars or to enter your bank account, to be that startup company that's going to create the future. You know, I'm not going to get into the math here today, but trust me on this. You need the promise of at least 100 million devices in the market for you to find a market for your product that is big enough to justify those investments. And that requires the first two criteria, but it really requires that marketplace reality. And what we haven't yet seen is presentations from Google and Facebook and Oculus and others that show us how this is going to happen. And this is, I guess, my peek at the inside for all of you. I've seen these pieces, and I know they come together in the beginning of 2018 and will be here in full flower in 2019. So I have high confidence that this market starts to accelerate because these things will be true. And when these things will be true, it'll start to accelerate. Now, I know that's a little bit of a tautology, but it is in fact the way it's going to work. And it starts to take off 12 and 24 months from now in a way that I think satisfies all of our greatest ambitions. Now, I want to wrap up with a couple of very, very simple thoughts. It's real this time. VR and AR is in fact going to be the final frontier. It's the thing that's going to matter. It is going to change the world, and it's going to be huge. The second thing I would say is if you know anybody that works at Oculus or works at Google on the VR business or Microsoft on HoloLens or other products that they're building or Samsung or Sony, whether it's Andy House or it is Clay Bavor at Google or Brendan Ariba from Oculus or other visionaries, thank them. They've invested billions of dollars, literally billions of dollars, to create the opportunity. And then look down the aisle in the row that you're in and imagine that that person, whether it be you or someone else, is going to be the one that creates the industry. I'm confident you will, and I look forward to working with you as you do. Thank you. Don't need it.
that scraggy, bearded gentleman with a lot of knowledge which he's going to impart to us is Matthew Mueller. He had a bit of a rough time coming down from Film City, but he's here. All right, before I go further, I'd like to introduce myself. Many of you all probably don't know me, some of you all do. My name's Anil Vanwari. I'm the founder and CEO and editor-in-chief of the IndianTelevision.com group, of which Animation Express is a part. You saw the promo which talked about what we've been doing so far, and what's our dream behind partnering with? What's our vision behind partnering with Animation Express? Animation Express, like IndianTelevision.com, was set up as a with one mission, with three words. I'll say it: engage, educate, and entertain. So this is part of our engagement process with the industry. By engaging with you all, we hope to educate you all in some way. And what Matthew is going to do is going to be a step in that direction. We see a lot of potential in the use of Unity for cinematics and for VR, and MR and AR. And as you heard the CEO say, by 2019, it's going to be a rocking industry. So you as professionals need to really start experiencing the product that's on offer and whatever tips that Matthew has to give. As far as Animation Express, going back to it, is that we're looking at doing many more such engagements with you all. And Quentin has said that we will, hopefully in different cities. We just about worked a little while ago with Adobe, and when we explained to the industry on how they could use the new hidden features of Adobe Premiere Pro. So for us, it's about, as I said, engage, educate, entertain. The entertainment part comes through the IndianTelevision.com group, where we produce the Indian Telly Awards, we produce the New Talent Awards, the News Television Awards, and we also do a lot of engagement and education through IndianTelevision.com, where we have a OTT Summit, which is happening sometime in June or July, where we bring together the entire ecosystem to understand what is the future for OTT. Is it SWOD? Is it AWOD? If these terms are not familiar, I'll explain them to you. I think you all would be familiar with this. And apart from that, we're doing the Content Hub. We're also working with the news industry to help them work with the latest technology. That's the IndianTelevision.com group. Education also happens through the news stories that we carry across IndianTelevision.com, AnimationExpress.com, RadioandMusic.com. Radio and Music caters to the FM radio and the music industry. Indian Television to the cable, satellite, DTH, production, and financial and DTH, all the sectors which are related to that. If you're a studio, you want to know what to do with a TV channel, how to sell to a TV channel, you need to log on to IndianTelevision.com. Animation Express is for all of you all: visual effects, comics, gaming, animation, the full Monty. Apart from that, Animation Express is also working closely with studios to help them syndicate and export their content globally. So in recent times, we've been representing few animation studios, taking their content to MIPCOM, MIPTV, ATF, to help them understand what the international markets are looking for. Apart from that, I personally represent Reed Midham's MIPTV, MIPCOM, and ATF out of India, Pakistan, Sri Lanka, Bangladesh. These four are my territories, to ensure that any studio going out of India, whether it's a VR or whether it's a film studio or a distributor or an animation studio, I assist them, my office assists them. I also look after the property market for India, Pakistan, Sri Lanka, Bangladesh. So if any of you are in property, please reach out to us, and we'll help you get money from large pension funds if you have a good enough product and your project is sound and you're making sure that you're following the Real Estate Regulatory Authority of India Act, which has just come into force 2 years ago. But coming back again, enough of my pitch. Matthew, whenever you're ready, just raise your hand. Are you ready? Great. So what you all really came for, you all didn't come to listen to me talk, but it was good to engage with you all. Thank you for coming in the numbers you all have. And we look forward to engaging with you further in other events and in other products, and look forward to your support always. And wish you all the best as you move forward in your journey in the wonderful world that we're all involved in, entertaining and creating the entertainment. Thank you.
Just waiting for the last cable to come. Okay.
So I also have Quentin States-Pule. I hope I've got the right pronunciation. Let's introduce him to you.
Hi everybody. Good to be back in Bombay. I recognize some face. So I'm Quentin. I run Unity in South Asia, which is from Pakistan to New Zealand, and we're really happy to be here. I really want to go to the content directly. I'll just say three things. We have three missions in the game business, and pretty much 1 out of 2 games that you will have on your mobile phone today is mainly with our tech. Our objective is threefold: is to democratize production of content, of solving hard technical problem, and ensuring that all the people who are using your tools are successful. We've done that for the last 15 years in the gaming industry, not by design, but because gaming is so close from VR. We happen to now have about 8 out of 10 of the experience created for VR and AR are made with Unity, and we are now addressing this market very head on. And we think we've got a shot at having the same impact in movie and television. And our biggest advocate and a person with the highest knowledge and have been involved in most projects in the movie and TV industry is today present. And so I'm very happy to welcome Mathieu, who hopefully will share many secrets and experience with you. Thank you all for coming, and thank you, Anil, for organizing this for us. It's very good. Thank you.
Yeah. So before Matthew begins, how many of y'all are from the animation side of the industry? Show of hands. That's about 15% or 20% of y'all. How many of y'all are from filmmaking? Okay, that's another 15, 20%. How many of y'all from VR and AR? Wow, that's lovely.
Yeah.
Great.
From the
How many
games.
of y'all are from visual effects? All right, so you're fairly well represented. So Matthew, you're talking to a bunch of people who understand what we're going to talk about.
How many people from games? Okay, wow. And are there people from nothing that we talked about?
How many students? I'll put my hand up. I'm always a student. Great. Thank you. Lovely to have you. Over to the great Matthew Muller.
Whoa, thanks. Maybe we can turn the light down a bit. So we are gone for, we're gone for like 2 hours something. I hope you will not fall asleep. I will do my best to keep you awake. So yeah, my name is Mathieu Muller. I work for Unity since 3 years. I've been working for 16 years now. I started as a programmer on rendering engines for flight simulators, so plane simulators, helicopter simulators. Then I moved to AI, working on NavMesh, pathfinding, and so on. I was integrator of the NavMesh pathfinding solutions into different game engines. So this was like 10 years ago, probably. What is funny is, at the time, like 10 years ago, I was doing a competitive analysis about which game engine to use. And it's very interesting to know how the things changed, because Unity was maybe number 4 or 5 on my list. At the time, it was quite back. What is funny and sad at the same time is, like, on the top 5 from the time, probably only 1 remains alive. Like, there were game engines like Gamebryo at the time, like Virtuals, Shiva 3D, Ogre is still a bit used now, and Unity was very small at the time. And then I worked on tools. I really like to try different things, and but what I really like is to talk about technology, and so that's when I started this job at Unity as a field engineer. So I travel, I meet the studios, I do training, consulting, and working at Unity was very interesting because I met people from medical, from film, from archviz, from automotive, from games, from mobile games, console games, any kind of things, and VR since like 2 years. And now I'm a film specialist at Unity, so I coordinate movement around films. I've been visiting many studios. My first time in India, so I'm very happy, and I just arrived a day and a half ago and already visited like 4 or 5 studios, and it was really, really nice. So for the people who welcome me, thanks a lot. and yeah, it's just like the more I travel, the more I see that there is something really big happening right now. It's this kind of, like, I feel very lucky because it's this kind of moment in your life, in the technological life, where you know that you are at a transition, a technological transition in an industry. I feel like, I don't know, working for Pixar in the 90s at the really beginning, or working on 3D engines, because it's really a major change. So just a few words about Unity. Who is using Unity here, maybe already? Okay. Who is using another real-time engine? Okay. So, so I just talk about Unity. So Unity, we are 1,500 people now, working all across the world. I'm based in Paris, as you can hear with my fantastic accent. And it was founded in Denmark in 2005. So the idea at the time was, let's make a game engine. Let's make a game. There were like 4 or 5 guys who wanted to make a game. So they created their own engine. It was really common at the time that you use your own engine, because most of the solutions were quite expensive too. And also because they were from Denmark, they only use Mac. So they say, let's make a game on Mac. So there is no user at the time of, no gamers on Mac at the time. And then their game was not really good, but the engine was quite good. So they started to develop the game engine. And because in 2005, like Unreal was here for already 10 years, there were other engines at the time. We decided that we cannot do it alone. Like we need to have a community together. We need to make an engine which is a platform that people can plug things around, because we won't have time to develop everything ourselves right now. So that's what we did until the year 2009, which was a big turning point, because the iPhone came, and suddenly being on Mac, when it was a stupid idea at the beginning, suddenly became an opportunity, because people wanted to play games on iPhone, and if you wanted to make a game on iPhone, you needed to have a Mac, so you had no choice but having a game engine on Mac. And then people wanted very quickly to make games on Android, because they wanted to make money on both platforms. And then people also didn't want all to work on Mac, so we did an editor for Windows. And then the community started to grow, basically double every year. And now we have 1.5 million users across the world which are using Unity actively, which means opening the editor at least once a month. And with time, we started to add more and more platforms, because this is something very complicated, and this is something that you cannot do when you do your own engine. Doing the QA on many platforms is just a nightmare. We have about 100 to 200 people just doing QA and tools for QA. And like we have maybe 10 people just working on Android just to support this platform. Same thing for iOS. Yeah. So, and what is super interesting also, there was a second vision at Unity. Like Unity actually was called Unity because we had this dream of making a platform where you, if you're a sound designer, if you're an animator, if you're a modeler, if you're a game designer, you can all work together on the same tool and doing the same thing at the same time. Like we really wanted to consider game making as music making. You know, you are a band, you are 4 people, and you can do a game. And what is really nice, we didn't make any game ourselves. So only the people using our engine were making games. And what we wanted is to create features and not create game, like take any consideration of gameplay or the aesthetic of the game. So when you look at this, you see that they are all different styles and they are all running with the same engine. You don't need to switch engine because it's 2D or 3D. They are working, like, for example, Hearthstone here, which is probably one of the most installed game, is running on almost every platform now. We have Lara Croft Go on mobile. Even the big companies who could afford making their own engine, like Rovio, like Angry Birds, they went from their own engine to our engine just to not take care about the QA. Yeah, so This was the point. And so why, like, the film and the game industry had this relationship that they wanted to, each one wanted to be inspired of the success of the other one. And I will go into more funny details later on about this. But the first way to do kind of films with Unity, the most obvious way is just to bring videos into Unity, and then you start mixing the two of them. So for example, Her Story. Who played Her Story here? Nobody? Okay, I recommend, if you have 2 hours, try this game. It's a game where you have a very basic interface. You are on the police search engine, and you have the first word, which is murder, and which gives the results of every videos, interviews of this woman where the word murder is on. And you see this, it lasts for like 40 seconds, and then you can type any word, and then it will bring all the videos with the words you typed in. And the more you watch videos, the more your mind is building up the story and try to recompose it. And actually, it's Sam Barlow, which is a very famous game designer who made this game. And there is a real mechanic hidden behind. You know, like you just type words, but actually, the gameplay is made so well that when you will have typed certain keywords, the game will know that you're getting one step more into understanding the story. It's a really, really nice game. It lasts for 2 hours. And I think it's one of the first examples where you, being just a cinematographer and making videos, you can come up with a gameplay which mixes the two mediums together. So this is the most obvious way, super cheap. You just have to put videos and a simple interface. And then I went to Los Angeles in November to talk about films and to meet studios. And I met a guy called Vince Parker who works at Warner Bros. And he contacted me, and we exchanged, and I actually visited the Warner Bros. Studio on the little cars. It was very nice. And he was telling me that he was on-set video playback artist. So normally when you make a movie, you have a green screen replacing the TV screen, and then you create something with After Effects, and then you composite it. The problem is like the lighting first. If you have a big screen, normally the actor is lit, so you need to make some tricks with lights on set, and it's a bit restrictive. And then you have to choreograph your actors because they don't even know what the UI looks like. So it's like, hey, do doot, doot, doot. And then you make it match, and it's a bit of a nightmare. So what he did on Passengers, which is quite successful science fiction film, all the UI of the film are actually made with Unity. And most of them are actually working, and the director was super excited, which was like, oh, you can actually press order something, you could change, there are some pods, sleeping capsules, and you can see the monitoring of the heartbeat, and everything was running live. And because he used a game engine, he was connecting it to a main computer and triggering some loops also. So for example, when the power gets down on the ship, every single monitor has to cut off together, and he was just like sending network messages to everything and just starting a loop for all of them. And now it's like they grow the team and have more and more people because they know that's the way to make their job. You know, they just do the same stuff as before. They make it a bit interactive, and then you can do it on set. He's working on a submarine TV show where there are like 50 screens all around, and they're all made with Unity, and the entire show is in the submarine, so it's like 20 episodes which all happen there, and he's working a long time with that. We have the
schéma de jeu que Rafter, mais il est le maître de l'agression.
So this was at
Le Suisse dicte l'échange dès le premier coup
it's
de
a French,
raquette et refuse de
the
reculer.
French television Eurosport went to the Australia Open a few months ago, and they did live compositing with a video from the presenter with Unity, so that it can be placed in the tennis court. There will be Roland Garros the French Open in 2 months, and they will do again the same. So they're building up the technology one by one. The tech director of Eurosport, Discovery, has been working on different setups for broadcast, like having interactive content for the presenters and so on, all with Unity. The Discovery application for VR is actually made with Unity also. They have tons of, like they put for the winter challenge this year, they put a 360 camera on the hand of one of the skier, and he had to go down the slope and try to be as stable as possible so that you can see how you go down the slope and what is complicated and so on, and they just uploaded this to the Unity application. So again, just mixing video and 3D. Also, I was surprised a few months ago to see that most of the 360 videos, just pure video 360, were actually running with Unity. We will see why. So this one is a very interesting one if you want to watch, if you're into 360 very good filmmaking, because there are people who worked on the film industry for a long time, and they gathered together in a kind of organization to pioneer into like feature filmmaking in 360 videos. And it was actually shot with like professional actors and with red cameras. So they were using like a rig with 2 red cameras. And when like you have the choice between having a rig and put it on set and starting to test the actors, but you cannot do all the lighting the way you were doing traditionally, and you cannot direct the actors as you were doing behind the camera. And also, if you want to make a rig with red cameras, it's not really possible also neither. So what they did is they cut into slices all their movie, just like when you cut a dialogue with 2 people, you just film twice, and they just pay a lot of attention to having the right lighting at the transition between the 2 slices. And all the movie was done this way. And also they decided that the back is not very interesting in most situations. So the back is CG because you're in the head of a robotic head of Philip K. Dick, a science fiction writer. And it's interesting because at some moment they really also redefine how you make your framing in VR. So there is a moment where there is a woman on the left, there is a corridor, which leads to a door, and the 2 main characters are talking right on the door, so the frame is actually made of a real door frame. And then there is somebody on the left sweeping, which is on the back. And it's really interesting because you have the possibility either to watch the movie or watch the second layer of the movie, and it's very nice. I recommend watching that. Again, some applications in VR. This is the first TV channel in France. The Voice, who knows The Voice? It's popular here, right? No? The Voice, the TV show, yeah. So like, the principle of the show is that you have somebody singing covers live, and the 4 judges have their back to the stage, so they don't see who is singing, and they can push a button if they like it, and they turn around and discover what he looks like. And so it was perfect for them for VR, because they made an application. So it's not live, the show. There is a lot of editing, like in many TV reality shows. But they synchronize the content with the live broadcasting. So when the time comes to watch The Voice, you put your VR headset on, and you're back to, you don't see the people singing, and you have a button that you can press. And when you like it, you can be the judge, and you press, and it turns around, and you see the people singing. So you can be the judge, and it worked very well. Like 500,000 people just in France use that. We had tons of people doing stuff. Chris Milk and Aaron Koblin, who are famous music video makers, they made some very nice 360 videos, also with Unity. We have some people also in the art space using AR. So Heroes is an experience where you have 2 dancers. It's very expensive because you need every spectator to have an HoloLens. But the dancers are dancing, and you have augmented reality on top of them depending on their movements. So why do all these people use Unity? Because in the end, it's just like playing a video somehow. First, because of the platform support. If you make an application and you want 500,000 people to use your application, it has to work on every stupid Android versions and device which is spread across the world. You want also specialized audio, and you have no choice than running something real time so that you know exactly where your head is, so that you can have real specialized audio, because the left and the right totally change if you turn around, and you also want to have binaural audio, which is sound over and under. Sometimes also you want to have a custom user interface and maybe to have some interaction where you can decide where you want to go. So, and I call it a VR vortex. So it's very interesting because game technologies get better and better in terms of rendering, but still the film side was not so interested, and the CG side was not so interested into VR, into real-time engine. But with VR, there is no choice. You know, you have to use a real-time engine. And then once you start using it, you need to be trained, and you start measuring the capabilities of this. And then you start thinking about your own pipeline, and you're like, oh, actually, I could make an application to speed up this side of the pipeline, or I could do this, I could do previs, and so on. So this is what happened after. So as I was saying, the film industry is very mature, and we have this rendering time which keeps increasing with time. So you could, like everybody was, I remember, I had a colleague actually 11 years ago who started a company to make real-time ray tracing, like, because they were like, everything will go so fast in 10 years that we can do ray tracing in real time, you know? And when you see that, it's a rendering time for films. It's just like we will never be able to catch up, you know? Like the rendering time offline is doubling every year on every single project. So there is no chance that real-time path tracing can catch up, you know? If this time would go down, we could at some point meet, but here it's just like going up. Almost 1 billion hours of computation of images for Moana. Imagine 1 billion hours of computing for one movie, which means incredibly big render farms, which means iteration time being totally impossible. So you just create kind of a big factory where everybody is passing the little piece of the movie to the next one. So one frame, 100 hours, if I exaggerate. I mean, in many cases, it could be only some 20 minutes for some applications, but still it's a long time. And then a year ago, like we have been doing a lot of the way you want to push your engine in terms of graphics, you don't make a game, because a game is interactive, so you cannot really measure if it's photorealistic or not, if the quality is good enough or not. So making a cinematic, actually, making a short film, is a good way to measure if your engine is good or not. And so we've been making, like, I think we made like 3 different cinematics in 4 years. And what is very funny is like nobody paid attention to these cinematics until Adam, which is our latest demo from last year. And suddenly, it was here. Like, we showed this, and suddenly we had people from the big film companies starting to call us and say, oh, we've seen Adam, and it looks great now, so this is the moment. So I will show you, who have seen the Adam demo already? Okay, so I will show you the Adam demo. It lasts 5 minutes. Sorry for the one who saw it already. If you already saw it, you can maybe look at this and think about questions you want to ask about it, and I can answer. Oh, no, you don't see anything, right? So, sorry, I need to duplicate the display. Okay, so here it is. It is a bit stretched because of the format. a light, please?
Hey! Come on!
Thank you. So, just to wake you up, do you have questions about this film? Yes. Who wants to ask questions?
First of all, what kind of GPU power does it take to run this in real time?
So I was expecting this one. So actually what the question was, what kind of GPU do you need to run this? So you see this is my laptop here. There is some wires, but so if I go here, everything you saw is actually real time. You know, I'm moving the camera here.
No, but you're playing the render. I'm saying.
No. You see, I'm
playing inside Unity.
It's playing live. I'm moving the camera. I can even move the light. You know, I can move the light. This is not a video. This was running real time. Everything.
Oh, okay.
Yeah. Okay.
Wow.
So, for example, if you go outside, I don't know, whatever shot, like everything is real time. You know, like all the rendering is real time here. Yeah. So yeah, so I have a 1060 NVIDIA 1060 GPU. Yeah, so which is getting like available for €1,000, I think, in like a laptop with a 1060 now is yeah. So it's yeah, that was the goal. Like our goal was to prove how far we can go in graphics. Actually, we didn't have any goal in making film at the time. It was just like, hey, how far can we go? And then suddenly it's like, oh wow, it's running real time and it's good enough. So yeah, it was. So do you have other questions about the?
Also, we wanted to know where many of the tools that you used in this will be actually available.
Yes. So
5.6 and some they had not been released.
okay.
So when are all the things coming out?
Okay. So the question is when the tools for this will be released. So the we have released all the assets for the characters and for the terrain on the store, and we have released a volumetric lighting package, which is a volumetric lighting that we used, and the atmospheric scattering also that we use on this. And this is all available and it's running on any version of Unity since 5.
5.6 will run out of this?
Yes, yeah. So one of the tools, I will talk about one of the most important tools here, which is a sequencer. We use the sequencer. So this is available in 2017, which is a new version, and it's in beta 4 since yesterday. So it's public. You can download it and you can use the sequencer. Yeah. So I will talk a bit more about the sequencer after.
Yeah. My question is, how many people worked on this to get it to where it is?
So thanks. So the question, maybe you people here. Everybody heard the question?
Yep.
Yeah. So 8 people worked on this. A producer, a director which was making all the layout himself. So he was doing the layout, doing all the story, doing all like putting all together things. Then we had 2 developers, one kind of tool developers and one more graphics programmer. So the graphics programmer implemented the atmospheric scattering, implemented real-time area lights, and integrated real-time area lights and volumetric lighting. I will give more details about this. One other guy did some tooling around this. So for example, the crowd here that you see, because it was only one guy doing all the layout, it's very long to place 80 people and make the different path. So the guy making a tool actually did a small crowd system where it analyzed where are the obstacles, generated some kind of motion path, and then we had a state machine which was using repetitive textures just like a game, and depending on the curvature of the path was using other animations, or randomly taking another animation so that it creates some variety. And then we had some contractors. So one specialist for the character. Like you really need good artists to make we took some of the best artists on each thing. So we had a specialist of a character. We had a specialist on clothes also, because there are a lot of work on the clothes. We had a specialist for all the environment, and that's basically it. Yeah, like 8 people. Yeah, and no, we had a film director and a professional actor for all the mocap part, and all we had a professional cameraman also that we rent, like that we paid for 1 day of shooting or 2 days of shooting, so that the camera work is really good. And yeah, that's about this.
And the cost would be what, 100,000 euros?
No, it's a lot more. Like it was across 8 months to a year. Not everybody was working full time on it, but we had the motion capture rental for 2 or 3 days. So yeah, it's more like 10 people. I mean, it's 10 people from Denmark and Sweden, so it's a bit more expensive too. But yeah, I cannot give the budget actually, but because I don't know, I don't exactly know what is the total budget. It's really hard to know because we also spent a lot of time giving feedback to the animation teams. For example, the sequencer was really halfway in development, so we were giving feedback and having issues. So yeah.
Can we say it was about 250,000?
I think it's more.
Okay.
Yeah, yeah. Because it's, I mean, that's the price of a demo. I think it's not the production price, because we were like really putting the stones. We were building the roads. You know, it's like once the road is paved, you can go faster on this. But yeah, it's an expensive demo for sure. Like every demo is quite expensive in game engines usually. Thank you. Yeah, thanks for them. Yes, there is a microphone. Yeah.
It was a wonderful demo. Great.
Thanks.
We have been working on kind of like animation in this thing. We are using some kind of like Kinect just to kind of like taking motion cap and giving cutting animation and giving it to character. But somehow I felt that still I haven't found out a good kind of like plugin for facial animation. Like Mechanim was having some kind of like facial animation plugin, but it is not supported as of now.
Yeah.
So is there any other solution for facial animation which is like main crux of say animation?
Yeah. So facial animation, yeah, no, there's not much right now. I mean, we support blend shapes, so you create your blend shape rig, and then you do exactly as you would do in a film production. You create your blend shape rig, and then you animate it there. You can import the blend shape from Maya also, but that's basically all we have right now.
Heavy. Yes.
Sorry?
It becomes quite heavy because if you want to have so many of blend shapes and then.
Yes, for sure. No, it's really like it's a work that will take some time to reach everything, because also you have a second issue with facial animation is to have realistic humans, which is already hard to do in CG. So yeah, so we're working on this. Like some people on the team are actually working full time. Like one guy who was one of the lead developer on characters on Rise of Rome for the game, and who was working at CryEngine, is working full time on facial expressions and performance capture, and to make it real. Like his goal is to release when he can, like as soon as possible, a demo where we don't have the uncanny valley, or we limit a lot the uncanny valley. We don't want to. Like I will show you later on the film that we've made with CG characters, and it's not as good. You know, you theoretically think it requires a lot of work, but yeah.
Sorry, another point is something like the difference in between the film's animation and the actually game animation is where you can see that principles of animation, like Lasseter talks about like principles of animation, anticipation and follow through. Basically, the thing is that that's what we normally miss, and which is quite difficult to imbibe in games animation, because we are actually taking the motion captures and cutting and using the predefined kind of like transitions. So is there any kind of like thing that Unity is working specially on this particular aspect?
So on animations like sequencing animations together and cutting them or cleaning them, you mean?
Okay, we will talk this one.
Okay.
On that one.
Okay, no problem. But yeah, I will talk a bit more about animation later on. If just what we support currently. We will see there are different techniques. Yes?
Hi.
Hi.
In your previous few statements, you mentioned real-time area light. So is that the Unity game object area light you're talking about? And if yes, is it going to be released for a real-time sort of lighting setup?
Okay, so very good question. So I talk about real-time area lights. So real-time area light is part of what is making this effect, like the lighting, very nice from everything we've done before. And it's really tricky. There are not so many engines who have real-time area light. And we open a graphics app. Sorry, it's a very long answer, but it's all right, telling story at the same time. So we opened a graphics lab in Paris a year and a half ago because Unity was more of a mobile game engine, and we had only like 10, 15 people working on the entire graphics for all the platforms, and we really wanted to push this further. So the graphics lab was opened by Sébastien Lagarde, who was the lead developer on the Frostbite engine. And he developed some real-time area lights for Frostbite engine at the time. And when he opened the office in Paris, he actually hired 2 research guys who worked at NVIDIA on a really like cutting-edge real-time area lights technology. And we presented it at SIGGRAPH last year. And it's really like the most cutting-edge real-time area light technology that we have right now. And because they were presenting this at SIGGRAPH, the guy from the Adam team were like, hey, give me your code, and I will try to integrate it in Unity. So they integrated it in Unity, not in the engine, but as I was saying at the beginning, Unity is a platform, so you can really plug into the rendering loop also. So, so it's a very long answer for this. All that to say that on the volumetric lighting package that you have on the store, if you type volumetric lighting, it's actually a GitHub, so you even have the source code of this. It's a drag and drop in Unity, and you have real-time area lights. It's a very long answer, and it's going to be even longer because so Sébastien Lagarde now is working on the next-gen rendering of Unity. So we totally changed the way we do rendering in Unity, starting already in 5.6, in parallel as what we're doing, and it's called scriptable render pipeline. So scriptable render pipeline, what is it? It's the fact that when you are a game engine, every AAA game, even when they use the same internal engine, what they change the most from one production to another one is the rendering pipeline. They will just tweak it so that it matches their needs. And when you do rendering, you have different ways and strategy to do it. And we didn't want to, again, have it in the engine and nobody can look at how it works and so on. So it's going to be in C#. So the rendering loop will be actually open source, and you can change it and hot plug it, you know. And so in this new effort, we will integrate real-time area lights directly in this new rendering loop. So it will be available off the shelf. And we actually have, like the research guys have worked a lot since last year. They present a new paper at SIGGRAPH. And there will be, because right now it's just square, like rectangular area lights, but there will be spherical and tube area lights available in the engine, yeah. But right now, in the meantime, you can use the volumetric lighting. I will show that after. Yes? Maybe the microphone.
I'm not very familiar with Unity.
Yes?
But I was wondering if it has support for MIDI programming.
For MIDI? So yes, so support for MIDI program if you want to control Unity with a keyboard or whatever. So we have a guy called Keijiro, who is a Japanese employee of Unity, and he's a DJ on the side and a VJ, and he's developing. I don't know how he's doing, but like he's releasing new things almost every week, and he has a Twitter. So if you want to follow one of the most creative guys around Unity, his name is Keijiro. Keijiro. And one of the things he developed a node-based system on top of Unity. It's a plugin called Clack, K-L-A-K, where you put some nodes and it will trigger events in your game. So it will trigger whatever you want, and you just tell what MIDI signal associated to that. So you can control, you can directly plug like MIDI into controlling any parameters of your game, you know.
So technically, you could make a video game based on playing music?
Yes, of course. Yeah. And basically, there is, if you want the level 0 of integration, it's called OSC. So there are many OSC plugins which are free and open source, where it basically just retrieve what is coming from the MIDI system, and then you have the data, and then you assign them to anything. He's doing like, if you look at what he's doing, he's doing VJing, and he has like MIDI controllers, and he's changing the lights, the effects, and it's really impressive. And it's all open source, what he's doing, so it's really nice. Other question? Maybe around Adam, because I have a lot of things to say. Just like to wake you up somehow. No, it's all right? Okay, I continue then. So, if you forgot the story, so Adam arrived and it kind of made this revolution. Because suddenly you're like, okay, now I can do some things which is visually appealing. So I can start considering using a real-time engine. And what do I gain? No more time waiting, because you always have your final image which is ready. No render farm. Interaction if you want to. VR, obviously, because you're running real time. I mean, you probably cannot run Adam quality things on VR, especially not on real-time VR, but the interesting point is all the process which is around. And shorter iterations, which means more creativity. And this is where I think the revolution is happening. You will know more about this. So the first usage of film where there was big interest was previs also. Like, it was a direct interest because you need these very fast iterations and you don't care about the graphics. So it didn't have to wait for the graphics to be good enough. So the Jungle Book from Jon Favreau was totally made with Unity first. Like the entire game, like the entire film was made as a game first, like not as a game, but just like a big cinematic, so that they can actually plan all the sets, because only the actors was real. So they didn't want, for example, one example, he's walking on a tree at a moment, and there are some leaves which are passing behind and in front, and sometimes the light is casting shadows on the character. So if you don't know where the light will be on the final shot, you will have to composite some shadows on top of the characters, and this is very expensive. You know, like casting shadows on post effects, it's a lot of people to paint it. It's very boring also. So what they did, they exactly knew from the before starting productions, they knew exactly where the light will be on the final image. So when they build the set, they just gave the game to the people building the set, so that they build exactly the same tree as what was made on the game, and then they put leaves next to the lights, so that they cast the real shadow on the actors, and they don't have to do any post on top of this. And then, so it was kind of pitch viz, so you do the entire film and you validate with the production that the story is good and everything goes together. Then you give it to the people making the stage, we call it tech viz, so people use it, and then you start filming, and you have the actor, and you want to make the frame based on what will be on the final CG. So you mix the video of what you have in your camera, like we did, like the broadcasting before, and you mix it with the game engine, and you can directly film on set. Another usage was like they tried to use VR at the time. Like it was like 4 or 5 years productions for this film, and there was no Oculus and stuff like this at the time. But they tried to use VR to choreograph also the most fast-pacing action, because the only way when there are the buffaloes coming to you and trying to evitate them is actually that the actor, the performance actor, can see when they are coming, so that they move to the left and to the right. So it's like when you bring this tool and you can take advantage of all the pieces, you can really build some useful tools for your production. Last week was FMX in Stuttgart, which is kind of the SIGGRAPH, a very big conference. And I had the luck to make a talk with Margot Durand-Rival. She's a previous supervisor on Star Wars Rogue One. And she was doing a talk with John Knoll, who was the FX supervisor since the beginning of Star Wars. And yeah, and it's what was the most impressive, like on the talk with John Knoll, they were showing, like, she worked directly with him and with the director, and you see the previs and you see the movie, and it's like it's the same. It's really the same, you know. And I was like, Margot, you did Star Wars, like it's incredible. You did the entire film. Like some people kind of made it clean, but you actually made all the X-wing and the camera movements. It's all you. And yeah, she was very happy to do that. And for the story, so why did I did a talk with her? So I presented her Unity, and I talked about Unity a long time, and I was like, why do you use I don't know, like all these very old softwares to do previews. Why don't you use a real-time engine? And it's like, you know, the third floor, they are quite big and they have their process and so on. And now she's working on a new company, and she said, yeah, we will see. And 2 months ago, she called me and she's like, I have to do a previs for a VR feature film, like $2 million budget for the feature film. And so we need to pitch it to investors. And we need to make 5 minutes 30 of a VR film, and I have 3 weeks, and I never use a real-time engine, and there is no tool to make VR previs. So she's like, do you think it's going to be all right? And I said, yeah. And yeah, and she did, and 3 weeks later, I visited her, and she had our 5 minutes 30 of previs, directly working on the Oculus, and for the story also, it's so this is the sequencer that is available, and that's why it's so important, this tool, because people like Margot who don't know anything about game engine, they almost only work there. You know, like they play slides, and then all the sequencing, all the story, all the camera work is happening here. So she doesn't have to, you know, to type scripts or to go in the engine. She didn't type a single line of script, which was actually a bit sad in the end, because when I asked her, how did you do it? She ended up saying, oh, like, what was hard? And she was like, oh, you know, each time you have to start from the beginning of the timeline, and sometimes I had to wait until it's the right moment and to record stuff. And I was like, oh yeah, but you can write a 2-line script and set the beginning of the sequence, and you press a button and we just run it alone. She was like, oh yeah, I didn't have time. But yeah, but she didn't touch any line of script. You know, you can use a real-time engine without this. And yeah, and what is interesting too is, like, she was doing previs. So for her, when you do previs, you have to handle a video at some point, and VR video. So we don't have export for video support natively right now, but we have the asset store. So we have many assets to export VR panoramas, 360 stereo, and so on. But the funny story is, like, she was working super fast. You know, like in 2 weeks she had been to the motion capture lab. She did the mocap. She did the modeling for everything. She put it into Unity, did the lighting, the volumetric lighting, the sequencing. She keyframed a lot of things. But then at the end, she was like, okay, I want to bake the video. It was 8 hours to bake the video, 5-minute videos, because it was 360 stereo video, and just the stitching, all the stitching of the 5 minutes of video at 60 frames per second was just, she super sampled it, so like it was 8K per image, and it was 8 hours of rendering. And she was like, oh no, like I won't have time to bake the video for you. And then the producer was like, but you use a real-time engine, why do you bake a video? You know, you just build an application and you give the application and it runs real-time. She was like, oh yeah. So she went to File, Build, it's like, okay, it's running. And it's like, it's really funny, like why baking a video in the end when it can be real-time, you know? So, yeah. And so there was, after previs, there were some usage of a studio in Japan called, oh no, sorry. First, this is a friend living in Lyon. And he worked both in the game industry and on the VFX industry. And like, I mean, if some of you have done the two of them, you also think for a long time that one day they will get together, and maybe it took some opportunities at some time to make the two of them. So he was contracted for this sequence, like 25-second sequence video, and he was like, okay, either I can do it again as I always did, or I can try to do it with Unity because I know a bit Unity, and maybe I will learn, and maybe it works, and maybe I can do more after that. So he actually did it, and it's still on French televisions, and it's running real-time, same stuff. Marza Animation Planet, this is another strategy. When you're a bigger studio, you have your pipeline which is set up. So you have all your artists know how to work, and you know that you're doing compositing in the end with Nuke. But the only thing which is a pain is the fact that it takes like some minutes or hours to render your images. So they were like, let's try to just replace the renderer. So They didn't change anything. They just replaced the renderer and render the frames, all the different layers of frames with Unity instead of using a path tracer, because they didn't really need to have a path tracer. There was no water or something. It was just like lights. So all the GI, all the lighting is actually done in Nuke after. I can show it to you. And their goal, so as an animation studio, was to move step by step. First, you replace the renderer, and you see if it works. And then, if it works, we can go one step further.
Working.
So they use this. It's 5 minutes, so this is just a trailer. They did this and really wanted to see how far you can push it. So you will see that they tried to push a lot of triangles, for example, at some point.
The world of crafts she's always played in spreads right in front of her.
So this is where they wanted to see how much triangles you can put.
Marsa Animation Planet unlocks the new possibilities of Unity. The gift.
So yeah, so for them the most important was this, like going to between, okay, with V-Ray and GPU, with GPU path tracing, it was between 1,000 something seconds per frame, or 21,000 seconds per frame, and they went down to 3 seconds, between 3 and 32 seconds per frame to render the final, exactly the same layers, and then they did compositing in Nuke exactly the same way. So for them that was the most important, you know, like instead of having this pipeline, which anyways ends up into a kind of custom tools which will retrace it at some point, why not just make the tools and you export. So what they did, everything was Alembic, so Alembic animation, so that they don't touch the animation. It's totally clean on what was done at the beginning. You put Alembic in Unity, FBX for the static places around. Then you put your lights in Unity, so that you can have a feedback of where the lighting is. Like even on the scene where there is something like a few billion triangles. Like we couldn't even show the number of triangles because we were in unsigned int for the programmers. We used 31 bit for the numbers of triangles, and it was not enough. And then after that, you just export an image sequence with all the layers. The limitation of this is that you need to create your own shader in Unity, so that, for example, the fur had to be made in Unity. You don't really care if it's real time or not. If it's kind of interactive, it's all right. So they use like a 15-pass fur shader, and then you create your own shader so that they output the different layers in different render textures so that you can export them. This guy also that I met in Los Angeles, they work at Pixar. Nest Num actually was. If you play many VR cinematics, like I don't know if you know Lost. Have you tried Lost on Oculus? It's a kind of the Iron Giant. I mean, he was animator at Oculus Studio, and he's animator on many films. So it's very dark with this image. So we don't see anything. So what they do is, like, after they come back from their main job, which is in my opinion very cool. Like, how can you do better than this? They actually have a kind of company where there are 40 people spread across the world, and they want to make a movie together. 26 minutes. It's going to be released at the end of this year. And what they want is, like, we're in 2017, and you want to create your own company, maybe. You know, like, some people created Pixar at some point, and there were a few people. And you want to live with your world. So many people want to work remotely. How do you work remotely if you have a render farm? How do you render any image if you don't have a render farm? If you don't have money, how do you do this? So they decided to use Unity and say, can we do films with this pipeline? and we make a proof of concept. 26 minutes, it's already long, with professional animators, professional lighters, and we see how it goes. So I hope, yeah, maybe I can pass it along. So all the lighting is done. We don't see much. It's already very dark, I have to say, on this trailer. So where it's very an empowerment is that it's a new creative process. It's no longer like it's the same as what happened with game industry and our whole idea of Unity. You know, like you really start making the final product from the beginning. So you start with storyboard. That was the actual storyboard of Adam. And then when the storyboard is done, you go in the engine, you do the blockout. You kind of know what you want. You know, when you write a film, you know that it's going to be a big wall, and you know that you're going to lie like Jesus at the beginning, and it's going to be orange and blue. And you put everything that you already know. You block out, and then you move in the world, and you find nice places to shoot. And then you take a cheap mocap system like perception neuron. There is a plugin for Unity, so they brought it into Unity. And then here you are. You have Adam version 1 after 3 or 4 days of production. And then when it's here, it's on your timeline. You can start working on the narrative. And everybody can start working on the project. You know, it's not like this guy is working on this, and one day we have a proof of concept, and then you start launching the industry on this. It's like you're done, and now you give this to the character designer, and you say, can you improve the character? And you discuss with him. And so you keep iterating on the same stuff again and again, and you see the quality improving. You make a second pass because you notice that the mocap is not good enough for the final tech, but in the meantime, you really validated exactly what you wanted from the actor. So you just have to, you have your reference, and you just have to make it better. Then you work on all the details. That was another programmer actually working on this. And then you end up being in one single place, and you have the entire movie in front of you, and you do the shot continuity, all the color grading, tone mapping. You can even move the light from one shot to another, because you can validate immediately that it won't be too shocking. You know, like if you think that the shadows are better if you put the light a bit up there, if it works with the previous and the next shot, it's going to be okay. And what is interesting, like we showed it at GDC last year, and the director changed a camera like 10 minutes before going on stage, or 1 hour before going on stage. You know, it was running it, and it's like, okay, it's good. Oh, maybe I change this one, and then he put it live. You know, and it's very empowering. So the guy what I've shown you until now is like demos, right? Like as you were saying, it was like, wow, that's a huge budget. And it's a demo, and it's our team making it with our engine. So I have to say it's a bit cheating, right? Because it's a proof of concept, and it's super interesting, super cool. But are we sure that everybody can do this? What is interesting is his friend who makes the sequence on Arte. He made his little pass in his life, and then he was like, okay, I can do a sequence, and I have this idea of a cartoon character made of cardboard, and I want to start my company, but I don't have money, so I will do it entirely with Unity. So he made this film with Unity, and it's 13 episodes of 2 minutes, and it was delivered in November, so you had no timeline that we have made right now. He actually took a timeline from the asset store. We have 2 or 3 versions of timelines that people made on the asset store, and he took one. And yeah, and he delivered the entire season of a series himself, and judge the result. I really love this cartoon. Yes, please. Thanks. Lights, please. Yes. It reminds me of India when I'm trying to taxi.
Ooh la la.
Thanks for him. So. Oh yeah, maybe if we have time in the end, I can show you. I can show. Yeah, I have two. Yeah, exactly. Yeah, I think I have the second one. Yeah, yeah. So, so yeah, here, like actually, this episode he did it alone, um, and but like there are some tricks to make it cheap. So the music is played live on top of the film. And the sound is making him himself live also. So he was like doing. So this you can cost the cost in this way. So this is the cost, 230,000 euros. For this is the production cost for this episode, for the 13 episodes of 2 minutes. Yeah, and 6 of 8 months of production. So it was him and a friend after some time, and then where they were heavy in production, like they probably took him like 5 months to get to the point where he had this first episode, which was really good, and then he had to produce 11, like 12 of them, and then he had 6 animators and modelers working on the production for the other episodes. He actually said that the 2 minutes format is a really bad one, because it's like long enough to require a lot of writing. You know, like there is just the writing of these episodes, like there are 15 stuff happening in 2 minutes, yeah, and it was like a long, very expensive to write and to imagine compared to what you get in the end for 2 minutes. Probably with the same investment of storytelling, you can have like 10, 15 minutes for the same price. And it was achieved using Unity 5.3, so like kind of long time ago, a year ago. So yeah, so this is the end of the first part of the talk. Unity for film is a reality. Like this was the most important. Like when we saw Adam, we were like, okay, this is the time. And then when I started to go and talk to many people on the film industry, I finally realized that it's not like it's gonna happen. It's already happening. You know, I met the guy who made this, and he's like, okay, I thought I had a great vision, and suddenly it's like you've been already doing this since like 2 or 3 years, and it works. And we have more and more productions, like for example, Baobab Studio, who is founded by the director of Madagascar. They are working. They have a demo right now, but they will be releasing Asteroids, which is a kind of cartoon, also very Pixar-esque and DreamWorks-esque, in the DreamWorks style, but which is interactive and in VR, and it's actually running on mobile VR. And they're using Timeline, our new sequencer also, so they are early adopters. They've been working on this, it's like 6 months. We have many more studios working on different things. Aardman Studio, who made this VR experience. This is me. I did a test, and oops. I got a test. So when I grab the radio, I'm in VR on this computer. When I grab the video, it starts the sound, and then the timeline is driving Adam, and then we can retarget animations. So I put a dance animation on top of it, and then I was filming live, like with the Oculus tracker. I just attach an extra camera, and I actually record the video live. So this is recorded at the same time as I render VR plus the third video. And there is a 360 videos around for the background, and some chroma key on the back. Another thing which I think is could be a great feature also is room scale entertainment. So mixing interactivity and film. Like I don't know. I have the feeling that in some years, maybe faster than I think, some every cinema in the world will have a space dedicated to this kind of entertainment, and it will be a format. You know, there will be a room which is where you can move the walls and move the doors, and people will create stories for this, and people will enter, pay the price of a cinema ticket, and go into it for like 10 minutes. You know, and you have so many, like, it's so powerful, so many stories that you can tell in 4 rooms. You know, like you just give, I don't know, 80 square meters, and suddenly you can start telling stories, and you give this to the people making film, and you can be a secret agent, and you follow a guy, or you can be whatever, you know, like it's so many, or just, you know, like you just take part of an historical moment, and you can be next to the table with the guy speaking and so on. And this is like what a lot of movie studio actually that I'm visiting are looking at, like how to build a cinematic experience which is really close to the movie one, but where you can be immersed in it. That's the big feature of VR. You know, like we didn't reach that grail right now, but I can tell you that there are hundreds and hundreds of people working on making it happen, and everybody wants to be the first to deliver this crazy experience. So what I think is, like, we are in 2017, and we are at a point where we want to tell a story. Like, a story is just a location, some lighting to make it alive, a scenario, some characters, some sound, and a point of view, you know, like a camera point of view, or something which is guiding you, a frame. And you want to make it interactive or not. You know, you have the choice. You don't have to make it interactive. I think we are out of the era of transmedia, where we try to create an interactive franchise on top of something. It's very hard to make. I think it has to be in the creative process. You build something, and suddenly, while you're building it, you're like, oh, actually, I can make it interactive. And then you don't want just this to be on a movie screen or on a TV screen, because people are looking everywhere right now. And also, you want to be able to iterate on every single stuff until the end. You don't want to be done with your project 9 months before it's released. You want to really work. You want to be implied, you know. And in the CG industry, I met a lot of people who are a bit frustrated. Some people who work on Titanic and so on, and they're like, yeah, but you know, my job now is like, I make these 15 seconds of the entire movie, and that's almost my entire year. And they're like, it's not so impressive in the end, you know. Like why they went into the movie industry is not to do that. It was to create a story and to create something amazing. And when they see that, even if it won't look as good, they don't care. They just want to tell again a story, and they know that there is tons of, tons of possibilities. It's funny because in my life I had a moment where I'm like when internet arrived, it was like, what can I look on internet? You know, I was like, oh, you can look anything, and I was looking for things to look on internet. And after sometimes I was like, okay, what can I do now? There's nothing you can do, you know. And then the mobile arrived, and then you're like, oh, we can make a game with a mobile which is doing this. And after like 10 years, it's like, what can you do with mobile now? Like, everything has been done, and you're like, what can we do? And suddenly there is this, and again you're like, oh, you can do so many things with this, and I won't have time to try everything. So I think we are in this moment, and that's why I'm here. And yeah, so that's the end of the first part. And maybe we make a small break. For the curious people, there is 150 more slides. Yeah, thank you for this first part. We make a, I don't know, 5 minutes break if you want to go to toilets, and we continue.
Yeah, stretch your legs and just get a breath of fresh air. Come back quickly because we've got only till 5 o'clock.
Okay. Yeah.
5:15. Thank you very much. It was wonderful. Yes. Round of applause for Matthew.
Oh yes, please. That would be nice. Thank you. Thanks for the great questions also. Yeah. But it will continue. Thanks for the one who survives. So in this part, I will talk about a bit more in details how you create things with Unity. That's where we start. You know, I just take again the story that we need to tell, so you need to go through all these steps. I think Adam is a good example because it goes through what you need to do to bring your assets. So for example, in Adam, modeling was done in 3ds Max. Marvelous designer with a bed and like for all the bed and the wrappings, it's a cloth system where you design clothes exactly like you would design them if you want to wear them, and then it simulates all the material. For all the materials, we use Substance Designer. I think it's very important because I'm presenting you a lot of things, right? And it's not like you can do anything with a real-time engine that's like that's the caveats. But I think one of the challenges is how do I get my asset into Unity and which asset I should go. One of the challenge for the film industry, for example, is the film industry, for example, a lot of people use UDIM, which has like infinite textures. You will use your own shaders with like you will do your own textures with Mari, for example, or you will do your own shaders, and that's a bit of a trouble, you know, like if you take a normal film pipeline, how do you get it into Unity? And we have a lot of companies coming to us and it's like, okay, it's cool Unity, but can you support OSL, Open Shading Language? It's an open shading language where you can give like, could we magically pass a shader from the film and make it run at real time, you know? That would be great. But it's really tricky because maybe we can pass the shader, but maybe it won't run because it's a totally stupid shader for a real-time engine. So I think Substance, for example, from Algorithmics, who is using Substance here? Are there people using Substance? Okay, nice. Okay, 4 people. So I think Substance will grow crazy in the next few years. They are also jumping in the film industry right now because because they just like Unity, they grew their user base like crazy. They are super efficient to create to do modeling, you know, like with all their Substance pack and so on. And so they are the reference for the film industry, and now they are really looking at the movie industry. And we have already TV series who are using Substance a lot. And what is nice also with Substance is like this industry is using Substance to just make things for the ray tracer. But when you think about this, it was made for game. So when you have something in Substance, you drop it in Unity, it's exactly the same. So suddenly the asset part is a bit solved. You know, if you're ready to change your asset creation, then this is solved with Substance. You have the same material and it's running, and usually it's smart enough. Because on the film industry, because we had no constraint on rendering time, we just put nodes together and it's like, oh, a bit more, a bit less. Okay, it looks good. It looks good on the shot, it's all right. But if you would change the lighting, maybe it doesn't look good. You know, you don't care about energy conservation. You just want this to look good in one shot. But in this new way of thinking, you really want to create an environment where you're shooting exactly like a normal movie, and you really need your materials to behave correctly on every lighting circumstances, so that the lighter has more power. For simulation, we use 3ds Max for the close and tearing. So we just took Adam, and we took the motion capture movement that he's doing, and like the actor was doing this, and then we just attached the hand of Adam, and we launched a simulation in 3ds Max, and we exported it as an Alembic file, and then we drop it on our timeline, and we actually, I don't show it here, but we actually made like 6 or 7 versions of the tearing with different parameters, and then on our timeline, it was like we put one on each track, and so that the director could choose between them, and because it's real time, you can see in the context of the clip which one works the best, you know, like if it's tearing and if the framing of the tearing and the material goes like when the pieces are going away, can we see them depending on simulation? So for the crowd, because it needs to run real time, it's not the full res Adam for the rest of the crowd. So we had the level of details generated with 3ds Max, and the outdoor is actually using a lot of tile textures. There are not so many textures in this movie, in this film. I would say there is probably, 50 textures. Yes. Oh, sorry. There is probably 50, 60 textures because like for example, all the building here has like 10, 12 textures. It's a Quixel mega scan. So we repeated it, and then we just put some decals and cracks on the wall, and it was making the job, you know. And for the ground, we actually used one material, and for this we created a tiling system. So we have multiple layers. So we had the puddles, we had the vegetation, we had the ground, and we had some details on vegetation. And then we made a tiling system which was rotating a bit randomly the tiles so that you don't see the repetition, and which is mixing all the layers in different ways each time it repeats, so that all the ground was like made in one go. To give details also on the ground, we had like, if you want it to be realistic, you need tons of rocks for outside. So what we did, one of the developer created a tool where you could shoot. It was like the director was going first person with a gamepad, and he was shooting little stones. He took like photogrammetry of little stones, and he had like a variety of 10 stones, and he was just shooting them, and they were just bouncing so that they fall naturally on the ground. And then he had he could remove them like with a cleaner, you know, like I don't like this one, and you remove them, because placing stones is like, you know, drag and drop, rotate, and it doesn't look right. So here, when you're in real time, you can just place stuff naturally. Like for example, so if you want a big pile of stones, it's very hard to place. So in a real-time engine, you just place physics on the stones. You just make a pile of stones, and then you run them at real time. And then when they stabilize, you just keep the positions of everything, and you're done. Yeah. For validation is very like look dev is a very important term in film. Actually, in games, almost nobody knows look dev except like the AAA studio, but most indies don't know the term look dev. So look dev is the fact that we had one guy working on the character, one guy or two guys working on the environment, and all has to come together and be correct. So when you use Substance, you are physically based, so you have a lot of chances that it goes well together. But sometimes you could miss your normal map or your occlusion map and so on. So we actually, if you see in Unity, it's very hidden. Not a lot of people know it. But if you go on Windows and Experimental, we have a look dev window where you can drag and drop objects, and you can put different HDRI so that you can compare two objects in the same environment. You can even, like, there are many tools so that you cut into two with two different HDRI to be sure that the lighting is reacting correctly with your objects. We use Marmoset toolbag at the time because we didn't have that. And there is a HDR HDRI pack that is available. So you can have different environments who are calibrated so that you can do the look dev in Unity. Environment, yes. So the setup. So when you start a project in Unity, so that's where maybe for the people who don't know real-time engine, I will start to speak Chinese. It's you have to choose between linear and gamma setup. Who knows what is linear and gamma here? Okay. Oh, nice, very nice. Do you want to explain? It's tricky. You want to try? Okay, cool. Do you have a microphone? It's cool, just to see. Is there a microphone?
Yeah, microphone.
It's good.
Yeah, it's coming.
So linear and gamma, we will know soon. We will have an explanation.
Hello.
Yeah.
Hi, my name is Vedant Saxena. I'm a co-founder of a studio called Enso Immersive, and we are creating solutions for different industries and the space of interactive virtual reality.
Nice.
So linear versus gamma it's a very crucial point, and most of the studios, they just skip over it. What primarily the difference is, when you're looking at an image on a monitor, it's gamma corrected for you. It's calibrated to the monitor RGB settings so that the image appears precisely, accurately, bright enough to your eyes. Linear, however, is a workflow that gives you settings that are more, which are more replicated of the real world.
Yes.
I would say.
Physically,
Yes,
correct.
yes. Linear is about 1.8 gamma value,
Yeah.
and a corrected gamma image is a 2.2.
Yeah. Yeah,
Okay. Yeah.
It's good. It's very hard to explain, right?
Yeah, it's a bit lengthy. I mean, you
Yeah.
have to really.
So
I would need a whiteboard as well.
So I insist on this because I really want it. Like it's a good explanation, and it's very hard to understand. You know, for people, it's like, oh, why are they 2.2 and 1.8 suddenly? Why everything is not normal, right? So that's why I made some slides to explain you, because it's something, you know, like even when if I don't do this talk for 2 months, I forget what's the difference between gamma and linear. So I come up with this. The question is, do you think that the more realistic is on the bottom or on the top? Who thinks that the top is more realistic than the bottom? There are two lightings here. Who thinks that the top is more realistic? The bottom is more realistic? And that's very interesting, because it is not the case. Look at that. This is a picture from a balloon in my room. And you see how the light is very fading away very quickly? Here it's fading across the sphere. And this is not realistic. It's just because in gamma, we don't have enough precision to stop the light very quickly. You know, like we have to spread the lighting very quickly. And this is what is making a video game style. You know, like when you look at the game, it's a detail, you know, like nobody will notice if I put the two spheres one after each other, what was the difference? But this is what is making the difference. Like if you go in linear lighting, you will have photorealistic, more photorealistic shading. So why there is gamma and linear? So the story, as you were saying, is the fact that it's a compression issue. It's the fact that our eyes cannot see very well the difference between very dark differences. So if you put on a paper every level of gray, almost 1/3 of the left, you cannot see any difference. Everything is black for you, you know? So they said, hey, we can save some space on the monitor, you know, when you send the data. Why do we send 32 bits or 16 bits of data when we could actually, because nobody will see the difference anyway, so we can just send like 10 bits or less bits. So, and that's also why JPEG is here. And so we made that for the monitors. Also, we made that because the monitors were not able to create this contrast by themselves. So that's why if you hear about this, sometimes we are like, oh, there are HDR monitors coming. It's just that right now in 2017, it took us like 80 years, no, maybe it's too much, like 60 years, to be able to have a monitor who is able to show the difference between a very black and a subtly little less black. And so what happens is, because of this, all our images are in gamma. When you take a picture with your camera, the film has a linear lighting, but then when we save it as a JPEG, we convert it to gamma so that it takes less space. And then because we will show it on a monitor, we keep this kind of conversion. So which means that instead of being on this, you know, when the gray is in the middle, actually the gray will be here, so that we have more space to put details on the very light gray. But there is a problem with that. So why? So first, the light is not reacting the same way. So there is a very good talk if you want to know more on top. So why is it a problem? Is the fact that the light, when you will start combining lights together, when there is a simple light, it's all right. But when you start going into the higher intensity, you start to have complete saturation of the light. You don't have any subtlety in the shader. You know, it's like a burnt image. Because you are not in a linear way, you're on this curve, which is not exactly reality. So so in a game engine, in most game engines, you can choose between linear and gamma. And if you want to do photorealistic, go to linear. But why it's not by default linear? It's because what we do, because all the source image are in gamma, and all the end image will be in gamma, because that's the way it works. what we do is like we want to do all the shading in linear, so we convert the image at real time for every image which is in the game. We convert it to gamma, to linear. So we remove the correction, so we go from the line underneath we add a factor of 2.2 so that we go back. Then we do the shading, and then we recorrect it just before displaying on the display, so that we have a correct shading. So it's a bit more expensive to run. So traditionally, all game engines have been gamma, but then since like 5-10 years, things are powerful enough. Especially this is happening at GPU time, and usually GPU is good enough. And we even have linear support on mobile since a few months. So if you want to do photorealistic, which means architecture or automotive or film, you have to go there. And then there is a setup, so that's where it gets more and more Chinese. So when you do rendering with an offline ray tracer, what you do is that you put some triangles in the world, and then you send rays, and they bounce on everything, and in the end you just look at what is the light coming back to you, and you display that. In a game engine, where is the magic? Is the fact that we don't do this. We just go to every element, we see which lights are lighting them, we light them, and then display every pixel on the screen in the end. So that's why we are not sending rays everywhere, we are just going through every object. All the objects which are outside, we remove them, and then we light them, and then this is the final image on the pixel. So, if you want to have, so the issue with that is like if you have two lights on a sphere, you will need to calculate the light on each pixel of the sphere. You will have to calculate the light from the light 1. So you draw once the sphere, and then you will have to calculate the light from the light 2, and you draw again this sphere. So you can have a shader which says, I calculate the two lights together, but then it's like maybe 4 lights, 8 lights. And then this is your rendering loop. You know, this is our code inside of Unity, is how do we manage all this rendering. And so through time, there were new techniques of rendering things that came out. So in Unity, we have 4 or 5 render loops, I think. 5 ways of rendering, like 3 are legacy, no, 2 are legacy, and 2 are new. And there are 2 render loops. One is forward. So forward is really, you take every object, you take each object, you clip them, you render every single pixel for every single light, and then you put the pixels on screen. So it's super nice because it's straightforward. It's a kind of ray tracer, but reversed. You know, you send rays from the images. That's why we call it forward. You know, like because it's moving like the rays. Instead of sending them here, you send them to you. But then there was a new technique invented. So what happened in the movie industry is like everybody was doing compositing. That's how you get the nice stuff. And compositing is basically, I take layers of my image, and then I will mix them in some way with some equations. I will mix the informations which are on the layers, and I create my final rendering. And so the equivalent in real time is called deferred. So when you choose in Unity, you can choose between forward and deferred. And deferred is the fact that instead of doing the lighting, the first thing that we will do, we don't render the lighting, we will just render the base, the layer image, like the layers, and we don't consider lights. We just say, oh, at this place there is a sphere which has a normal like this, which has an occlusion like this, which has a specular map like this, and this creates this image here. So we see we have 4 buffers, and then you do a second pass where you will look at every light, and you will do compositing live on the second pass. So the G buffer is kind of your compositing basics, and then your second pass where you do the lighting. What is great with this is that you can have as many lights as you want. You can have more lights because you have done the rendering of objects only once, and then you do a pass where you do the lighting. So if you want to have more lights, usually you use deferred. And we will see that there are some advantages. So basically, if you want to have a lot of lights running at real time, you need to go for deferred. If you do VR, you probably go for forward because you are not. It's costing too much energy to go. Like it's quite high resolution VR, So you need to create 4 high-resolution textures and generate them, and it's quite expensive to do this on VR at 90 frames per second. So usually you go for forward, and you try to not use too many lights, and we will see how you bake the lights. And then the last setup that you need to do is your camera. Yes? Yes, I will talk about this after, yeah. So HDR, that's the last setup that you do. So the big issue, why I'm telling you this, is that like Unity, we build it to be a platform where you control everything. And by default, when you put a cube, it looks ugly because it's in gamma, it's in forward, and there is no HDR camera. You know, so that's why you have to set this up, because we are also a mobile engine, so we don't know exactly what you will do. So the last thing is to do HDR. HDR is the fact that you know, when you are in SD, you don't have much precision. It means that the image that you store have not a lot of precision. So when you have a light, for example, you want a very dark atmosphere, and you have a small light, very quickly you will have shades of gray, and because you are not able to show all of them, you will see bands, like you will see like these circles going away from the lamp, because you don't have enough precision. So that's where HDR is important. You do in HDR, and you can suddenly represent all the different shades of gray from the HDR precision. So if you want to do, again, something good, like, so Adam is set up HDR, deferred, and linear. For the character setup, we have 3 ways to do the setup. So what we did was motion capture. So we did a rig in Maya or Max. Then we had motion capture on top of it, and we imported it in Unity as a generic rig. So we exactly keep the same rig as the one in Maya, and then we exactly keep the same animations and run them on top of the animation. So it's just like running real-time animations. What you see in Maya is what you get here. The second way to do objects, so that's what we have if you take the Adam package on the store. It's not the generic rig that we use for the motion capture. What we have is retargeting. So what you can do is instead of keeping the original rig, we have an iKey rig, which is our rig of reference, like a humanoid. And we do internally a kind of mocap so that we record the animation on top of our own rig. And the advantage of this is that you can reuse animations. Any animation which works with this rig, you can apply it to your character, and any character, you can apply any animation on it. You know, so you take any character, Adam, blacksmith, whatever characters, you import them as humanoid, and then you can take any animations from anything else and plug it on top of this. I will show you a bit of this just after. And when you have iKey, then you can, just in Maya, you can have iKey controls, and you can start moving the controls and doing some posing in the real-time engine. And if you animate the iKey pose, you can start animating in the engine. So for final posing, for example, it's quite nice. Margot, when she was doing the climbing stuff, because she needed it to be exactly at the right position at the right moment, depending in VR if you can see the ends or naturally or not, she actually did all the posing like this, like just with iKey. Scene management, so when you're working on the project like Adam, you don't want to work on just one scene, you know, because it's going to be one file. So which means that you have to say, oh, I don't work because the other one maybe will save this scene. So in Unity, you can have multiple scenes. So for Adam, we had one scene for everything which is cameras and lights and so on. One scene was storing all this, and we had a scene per environment, so that the environment could be worked separately as the main scene, and then you cut it in scenes. The layout, yeah, we jumped that because we run out of time. I mean, layout is just like in any software, you drag and drop stuff and you move them around. For the camera, just a tip for people using Unity, you have a fly camera if you right click and you go WSAD, you know, like you can fly in the world. And then in Adam, we had the camera was totally motion tracked, so it was motion capture. We just put a tracker on the camera and we just replay this as an animation. when you want to do something interactive, a part interactive, we have a lot of scripts like free camera if you want to travel around. And yeah, and this is important. We're working also on a physical camera where you can, like in a game engine, the camera is just what is the field of view. You know, you're like, is it opening to 60 degrees or less? We don't control, we don't have a 50 millimeters lens or something like this because it doesn't make sense, right? Like it's a constraint of the reality. And in a game engine, the only thing is how open you want to see the world, you know, like what is your field of view on the world. But all the ray tracers, almost all the path tracers, have physical lenses. So we're working on physical cameras so that you can work also, if you're a director, you can actually say, this is a lens of 50 millimeters with a backplate of a camera, backplate with this, and this lens distortion, and we create all the camera which is matching this. So we're working on that so that we can plug Unity to path tracers. This is one of the things that we think is important, is to be able to use that Unity data go through this, and you can still export them to path tracer, because we will never be able to do as good as path tracers. But you can maybe work on the real-time engine and finalize things on the path tracer. So you really need to be just a platform. And the lighting. So the lighting in a game engine, again, it's a bit more complicated than in path tracers. I'm feeling like a teacher, like everybody's sleeping, and it's like, oh, when it's ending. So I don't know how can I save that. Okay, anyway. So in lighting, you have the ambient lighting. The real-time lighting is ambient, so you just say how much everything is lit. Then you have the direct lighting, so which will, like, there is this light and it touches it with some attenuation, and in the end this is the color of something. Like you have a white light on a white sphere. If the intensity is 1, this will be totally white. Like this pixel will be white. This is direct lighting. But then you have indirect lighting. So for example, if you have a sphere, if I put a sphere here, a lot of the lighting is not coming from the direct light, but also from the fact that I reflect the ceiling, because it's like, imagine it's a chrome sphere. Most of the light is actually coming from the environment. So, and so that's one indirect lighting. The second one is the fact, like you remember, as I was telling you, that instead of not sending some rays in this direction, we send them this direction. So you're like, oh, why is the path tracers are totally stupid to not do this? So the reason is that we are cheating because we just have direct lighting this way, you know. And in reality, when you have a red wall and a white ground, if you send a light on the red wall, actually your ground is not white, because the light will bounce on the red wall and it will be a bit red on the ground. And this is what you don't get with direct lighting. So for this, we cheat. And the way to cheat is to put a texture everywhere on every single object. And we will launch a ray tracer, so we don't go away with that. We launch a ray tracer which will launch these rays and store this red color on top of the normal color. So we bake it so that we don't have to compute it at real time. So that's why so when you create a scene, first you decide ambient, then you place your lights to have the direct lighting, and you will have, if you have normals, it will shine a bit depending on the normals. But if you have a white character next to a red wall, or a white object next to the red wall, you will need to bake these things, and you won't be able to move them. And then you have shadows. So this is something we compute again on top of everything, because we were very lazy. We sent the rays this direction, so we didn't know exactly where the light was not going, because we don't know that. So what we do for this, we place a camera where the light is, and we will draw the scene, and when we draw the scene from this point of view, what we draw is everywhere where the light is going. So if we inverse that and reapply it, it's going to be all the places where the light are not going, and we reapply it on top of this, and it creates the shadows. And the issue with this is usually that because it's depending on where your light is, you will have, if your object is far away, you will have your object very small, and the shadow behind will be like some very pixelated stuff. So that's why there are tons of techniques that we have. where you do some filtering and you can blur it so that it looks kind of natural. And that's basically what is the difference between real time and offline. It's like we make tons of tricks so that it looks real, when actually we just try to fake it like a magician. You know, like when you're drawing, actually. You know, when you draw something, you don't send the light rays. You just say, oh, there is a shadow, I do this. So this is the way it works. And then on top of this, to make the final image good, you had post-processing. So you will do all the colors, grading, like what you do in normal films, and depth of field and so on. I will talk about this later. So this is this, but it's complicated, but that's all, you know? Like, when you get this, you know how real-time engine is working. You already know this, and then you have to work with that. So yes. So yeah, I'm just going through this, but I think I already killed you a lot, so I will jump on that. So for Adam, we have the ambient lighting, which basically defines the most darkest place in the room. Then we had some reflection probes. So the probes are things which are taking a picture of the environment that we will reapply on objects so that they have these reflections. And we cheat again because we don't put a probe every centimeters. We put few of them, and we count on the fact that they are kind of good enough so that nobody will see the difference, you know. If there is, for example, this table is reflective, and the ambient lighting is a bit white because the ceiling is white. If it's white because it's reflecting here, it won't change much, you know. Like, we put just one reflection probe, and we just apply this and mix it very subtly with the material. So in Adam, we just had, I think, a few, like for the entire game, we had this amount of reflection probes, and it takes care of reflecting all the lights on everything. There is nothing bake in Adam. You know, when I was talking about global illumination that you need to bake, there is nothing bake, because most people don't notice the bounce of the light, you know. Nobody noticed that the ground, when the sun is hitting the ground, which is a bit greenish, it should have been green on the bottom of the wall. Nobody cares. So we didn't do it, and it looks fine. This is the placement of the probes. So here yeah, it's too dark, you don't see it. And then we have this volumetric lighting. So I recommend, if you need volumetric lighting, to use this volumetric package. It's very nice. I have actually this running here. So this is a real-time area light. And you just add a component on your camera which says this is a volumetric fog. You say how dense is the fog. How do you want an offset to the fog? Like, do you want it to be everywhere or just to a special offset? Then you say how much noise you want in this. Do you want it to be anisotropic, which means does the light kind of does the light get kind of stopped by the fog itself? The more it goes away from the source, and then you can put a wind also. So I put a wind here, and you see that it's moving. And you even have, like, we compute the shadows in the fog so that you can have the thing, and everything is running like real time. So if I duplicate this cube here, you have the second one. So yeah, it's a small example. So so for this, just checking the time, yeah. So for the lighting, what we had, so for this sequence, it's very dark. Maybe you can turn a bit of the lights again, sorry. Because I will talk about lighting, just how we set up the lighting on these kind of scenes. So you want the light up or down? Down, yeah. Yeah, because it's very dark, so in this shot here, we have the light coming from the window here. So we placed an area light on the top. Yeah, okay. Okay, very good. Do you see me? So when we wanted to lead this scene, we placed an area light on the top here. And what we wanted to achieve is to have this very nice lighting on the fog. But the thing is, like, if you want this kind of lighting, you have to put a high intensity for the light. But the problem is, like, if you put a high intensity, it will start lighting the entire scene, and you don't keep this kind of mysterious background. So on our volumetric package, you control independently the intensity of the light on the fog as the intensity on the light of on the objects. So here, you have a very intense light for the fog, and a very low light, which gives this subtle lighting on the room. Then, we had some neon lights, same stuff, that are lighting the fog a bit, and almost lighting nothing in the area, so that you don't have light leaking. Then we had some small tube lights again to lit the particle system on the corner, and these ones, they have a point light on top of it, so which is the most simplest light that we have, so that it lights the red areas around. So you can choose the radius, and you get the red areas around. And then finally, because we wanted to put, it's exactly like in photography, usually you want to put attraction to the character. So we actually put an area light, you see it here, just behind him, but because you're in virtuality, you don't have to display the light, and it's just displaying. So we kind of fake the lighting here, so that we have a very good contrast here. And we do this kind of setup for every single sequence of Adam. And this lighting is placed on the timeline, so that you can change it at each time the camera is moving, you can change it. So I won't go through every shot, but like on this one, we had crazy number of lights. For this one also, it was like we had all these lights placed around, because you're really working on your light like you're working with the material, exactly like a photograph does, you know. So for example, one example here, this is very important to the storytelling. And to get this, we had a small spotlight pointing it directly at the head, and we made a mask so that it, like we decided that you can decide in Unity, it's called culling mask, you can decide which object the light affects. So we say this light only affects the eyes, so that we could point a small light just to the face. And yeah, we had tons of lights to get the nice rim lighting around also, and so on. This one also is interesting, many lights on top. And this is great, you know, like as a lighter, it's a really different process than working on a path tracer, because you are always seeing, you're targeting the final result all the time, you know, you add one more light, one light here, until you get exactly what you want. It's more kind of real somehow. It's not like you push a button, you change a parameter. No, you change a parameter, you push a button, you wait. Not good, I change, I push the button, I wait. You know, you just play stuff directly. So the methodology is a bit long. I still have 100 slides. We will go for image post-processing. We can, oh no, yeah, okay. I make a small game so that you wake up. So do you speak post-processing? So it's a game, you have to shout the name of the effect that will be on top of the image, okay? So just to see, so it's also for gamers, because yeah, in game engines, a lot is in post-process. So, okay, ready for the game? 3, 2, 1, go. What is this post-process? I start with a very hard one. Sorry? Bloom, excellent. You won. I didn't put an animation, sorry. Motion blur, excellent, very fast. So you see, so sorry for the bloom, for the people who didn't get. You see that the light, it's kind of blurred around. It's not bouncing exactly. It's kind of blurred where are the highlights. So in a ray tracer, you have to simulate that. You know, like you have to send hundreds of rays so that you can simulate this bloom on top. Here, it's just an effect on top, and I mean, you're also using this in CG production. Motion blur, you just keep the previous image, and you just look at what's moving. Motion blur. Okay, ready? Easy. Yeah, lens flare. It's an easy one. This one is hard, I think. No. 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 I mean, there is all of that, but it's like there is one which is very special. I'll give you a hint here. Yeah, chromatic aberration. So chromatic aberration is the fact that when you use a lens, it will kind of spread the light on the side of the lens, and you will have the spectrum of lighting which spreads across. So it gives a kind of television feeling or real bad lens feeling. So the game industry was very funny because when you want to feel realistic, you actually put you simulate shitty material, you know, and the cinematographer, he pays $100,000 to have a perfect camera, but in games we really want to simulate a shitty camera. Chromatic aberration. This one, you won't see it. It was grain, but you don't see the grain, right? So the grain is to simulate the film again. Again, you really want a very bad film, and so that you have a lot of grain, you know. But this is kind of artistic somehow. Grain. This one. No. Not fog. Depth of field, yeah. So it's simulating the lens. You have the focus here, and it's blurry. And this is really used in games. So for example, when there are some games where when you get hit, you get the depth of field which is narrowing, so that suddenly you cannot really see what's happening on the back, and it's harder to fight. And it's a good representation of this. I mean, film industry also. We call it DOF, depth of field. So this one, it's a mix because there is a motion blur also, but there is something special. I don't know if we will see it. We see 2 minutes. Do you see that? You see this stuff here? It's again. So it's not a lens flare. So like a lot of people make a confusion, because you see the lens flare wouldn't be on top of this. So yeah, so it's called lens dirt. Again, we simulate that the professional cameraman forgot to clean his lens, and you have the fingers on the lens, and it looks super real because who in a game who forgot to clean his lens, you know? So then it's real. And this one is you already said that before. No. So you see that there is we have the feeling that this is happening in the 70s on the original film, right? Why do we have this feeling that it's... yes, there is a bit of vignetting, but there is something special. How do you travel in time in a film? How do you take a... Tone mapping, exactly, and color grading. You know, that's where you get this feeling that it was old. And yeah, so that's it. And this is like super important for the language of the cinematographer. You can translate the mood. You can translate the mood of the location. If it's like very warm, you will have a lot of bloom, so that you have the feeling that the room is filled with light. You can translate the mood of the character. So if you have some vignetting, you will know that the character is into his stuff. Or if he's hurt, you will have a kind of red vignetting. You can travel in time, as I was saying. You can represent a point of view. If you add an overlay, you will know that you're a robot, or you know that you're a camera, because you have this very bad chromatic aberration. So in Adam, we use a few of them. This is a list. And this is, you know, like this is everything we used. And you can take a picture of this, but thanks God, this is not the way you will work, because it's awful, you know, like, how do you know which one to take, and what, like, each one of them has like 20 parameters. They mix like 4 or 5 different packages of post-processing things, like they pick a different bloom and so on. Sometimes they even switch the effect on like a different algorithm on different shots. So it's like horrible. And even worse, when you put them on the camera, you cannot put them in any order. You know, you have to put them on a certain order. And that's horrible. Like most people, when they use Unity, first, most of the people didn't know that they are post-processing, because you need to pick them on the side. Number 2, you put them on the wrong order, and it looks very bad. So Unity was suffering of, this is not, like this engine looks crap, you know, like, and their engine looks very cool. So what we did, we hired probably the 4 best guys on post-processing, like they are kind of specialized, and they have been working for a year and a half, and they released, it's actually not anymore in beta, a post-processing stack. So now you just drag a single element on screen, and then you turn on all the things you want. It's already on the right order, and it's already working. And there are some of the best effects on the market. I will try to show you a demo. So this is an asset. What I will show you is an asset from the asset store. Okay, sorry. Do you want to listen to music? Okay, so this is from the asset store. It costs 40. Yeah, exactly. It cost $40, and it's an interior apartment with ArcViz materials. And this is how it looks, right? So you see that we have some issues. So you see how it's flickering a bit? It's not so realistic, right? You see the things here, you look there. It doesn't look, I mean, it looks pretty okay. We will go to the bathroom. If anyone wants to go to the bathroom, it's now. So we go to the bathroom, and suddenly it looks really ugly. You see this stuff? This is killing the experience, you know? So what we do is Control Pay. So it's quite simple. We will actually, let's enter play mode. Okay. So what you do, you take your camera, you add a post-processing behavior, and we will create a new behavior. Like it's all your post-processing is happening here. Post-processing profile, we say, we call it Mumbai, and we go there, we drag and drop Mumbai, and we are ready to start playing like the game before, okay? So first, anti-aliasing, I didn't talk about this. So we have a fast approximate anti-aliasing, and we have the temporal anti-aliasing. So you will see now that most of the things which were already with this, you see there is no more flickering. You see that? Can you see it a bit? It's not so obvious, but okay. Let's go again to the bathroom if people want to like miss the last occasion to go to the bathroom. You see how now it's kind of fluid. Like there is the noise of the projector, but you see that it's not noisy anymore. Let's turn it off and see how it was before. You see the difference? How it's flickering everywhere. Yeah. So then we can add ambient occlusion. Ambient occlusion is again, we cannot send rays. So we fake the fact that the light cannot go on the corner, and we simulate it on the screen. We can push it so that it's really dirty, or we can make it subtle so that it kind of had some realism. Okay, we make it like this way. Then, you see, when I was talking about faking stuff, you see that this reflection on the ground? It's all right, right? But if you look correctly, it's not at the right place. You know, it's just like we put a reflection probe here, and it takes a picture of this image, and it kind of places it wherever it wants. Actually, if we move, we will see that the reflection is not really correctly placed. So what we do is we fake being a ray tracer, and we will send some rays full screen. So you see screen space reflections. Yeah, actually we see it more on the side here. You see that the mirror, let's go at the mirror actually. So the mirror here, okay, it's reflecting the light. If I don't have screen space reflections, it's making a fake reflection. It's not the correct one. It's just like, so, but you see it's very subtle. You can gain a lot of processing time by not using things if nobody sees that. Depth of field, so we can use the camera FOV, and you can decrease the depth of field. You can choose which distance you want the depth of field to be. Yeah, and suddenly it's kind of photorealistic, you know, because depth of field is what is making everything great. But you know, it's not too hard to use, right? We can add motion blur, so it gives a more kind of cinematic feeling to the movement. If we put a lot of motion blur, sometimes the games, the race games, you want to feel that you are going very fast. So you blend the previous frame with the other ones, and you have, or if you're dizzy, you know, it's kind of, I'm going so fast, backward. Okay. Oh no, I shouldn't have done that. Okay. again, but it's not, it's all right. Up, put it back. Up. Okay, anti-aliasing. Okay, let's continue. Adaptation, we keep it for after. So the bloom now. You see the light here? It's a bit harsh, right? It's not really bouncing. There is always light bouncing on the atmosphere. Let's put some bloom. Let's put some more intensity. You see, suddenly you feel like the light is going into the, is really living into the room. Oh, I have this crazy motion blur. We'll stop directly. And then it's kind of nice because the assets are of good quality, but you don't have this cinematic look. So let's do color grading. I just turn on color grading. And then we have these filmic ACEs for people who are in the film industries. You know that ACEs is a standard for colorimetry. So we have this filmic tone mapper, which directly gives you the right tone mapping, which is the most used in the industry. So it's a bit underexposed. So I underexpose. And now you see that my tone mapping really gives sharp black colors and really white colors. If I want to overexpose, because we're in architecture, everybody likes overexpose in architecture. If you want a bit more warmer place, you can do this. If you want a colder place, you change the temperature. If you want, like also in architecture, sometimes you like when it's not saturated because it looks cool. And it looks so cold, so I play this. You can push the contrast, or you can decontrast it also a bit. And actually, what we have here, we have a bunch of tools which are copied from, like, no, sorry, not copied, erase that, inspired by DaVinci Resolve, which is the most famous color grading tool on TV and films. And you have all this stuff that allows like a professional grader to find back his kid. So you have the parad and the vector scope, and it's actually moving with, real time, Like for example, so what is the use of this? Is like, like you have this problem. My color looks good in my computer, but maybe if I show it on another screen, it's totally green, because my computer was not calibrated and it was not correct. This is measuring the absolute color. If you're center around this, it means that it will be good on any computer. If you're like this, you know that it will be green on any computer, and if it's not green, the monitor has a problem. So this is like professional tools. So yeah, and this is something, we are the only one to have this on the market. Like some even like film company don't have this in their pipeline. We have all the grading curves and hue saturations curves and so on. Then we will use the chromatic aberrations because we have a very bad lens. Sorry. So you see how it's becoming TV style on the side? I will push it even more. Chromatic aberration, you see? You see how the colors are? So you feel really like that it's a very bad camera system that is doing this. Then you can add some grain if you want to have a kind of film. Actually, in Adam, we have a very subtle grain, so that it gives the feeling that it was, again, shot with a camera. You can add a vignette. It's very hard. Just press the button. You can have a strong intensity if you're very tired, or you can make it very subtle. But when you make it subtle, it really changes still the style. Oh, something I forgot to add, because we have again a very bad camera, is that you can add dirt on your lens. So we have some textures coming together with the back, and I will make it very intense. Where is it? Here. So that we really see that it's dirty. So you see when I'm looking at you see here, we see the dirt on the screen. On the bottom here, we see it here also. And again, you have the feeling that you film with a camera. Okay. And then we have something which is also top technologies is dithering. So dithering, sometimes even when you are in HDR, it's not enough to have the bending. So here in this scene we are very bright, so it's all right. But dithering is something which was invented by the team from Inside, which is you put blue noise, it's called blue noise, and you have different rotations of this on top of the image so that it blurs the lines between two different degrees of shades, and it's like really magical effect. And you gain on the bending like for very cheap. So all this is running. It's taking, like, screen space reflections is the most expensive, so try to not use it too much because it's sending ray traced rays, and sometimes it doesn't worth it. But if you don't use screen space reflections, all this cost is to do all these effects. It's about 0.8 milliseconds on a PlayStation 4 to run it. So, no, sorry, 1.2 milliseconds. The anti-aliasing is almost 0.7, 0.8 milliseconds. So you can add this and it's just like 1 milliseconds budget. So now we have a good looking engine. Let's go again to the bathroom because I love it. And see, oh, actually I can show you my room. Yeah, because this is my apartment. No, I wish. So yeah. Okay. So this is post-processing, and you see that it's not too hard to use. This is the version 1. We are working on a new version actually with even improved effects and capabilities. And what we want on the version 2, like what we have, is like you can place a volume in your scene, associate a post-processing, place another volume, associate a second post-processing because maybe the mood is not the same on two rooms. And if you're doing something interactive, you actually want that you fade smoothly from one mood to another one. So automatically, when you place these two processing volumes, when you will go from one to another, it will slowly smooth to the two atmospheres. Something else, something that I didn't show was also eye adaptation. So what we do in reality is like our eyes is adapting, right, to the ambient. And in VR, it's very important because you don't want to, if you have a very dark area and then a very colorful area, if you don't have eye adaptation, one will be saturated in colors when you enter and the other one won't be. Here we have eye adaptation, which is automatic. You choose how much light you want at the maximum and how much light you want at the minimum, and it automatically adapts. So if we see here, if I look on the side, okay, let's look here. It's very subtle also, and that's where it's really well made. You will see that if I turn around, it will pump up. You see, up, it goes up, the lighting. And then I turn, it goes down very slowly, exactly like our eyes are doing. And this is actually running, this algorithm is running on the GPU on every platform, even on a mobile platform, so that it doesn't cost anything. So that's it. Spotify, no. Okay, how much time do we have? We have 2 minutes. Woohoo! So anti-aliasing is a bit important one, but I don't have time. So we have like there are 4 different ways, but I really don't have time. And I have so many things to do. You can see the differences here of quality. Yeah, and these are all the post effects that I showed you. I really wanted to show you that. Animation I show you already. This is our new animation window where you can multi-select animations and scale them, and our animation window was not at the good level until recently, but it's better now. And we made a lot of work on particle systems also. Like this is all the new features which happened on the last 3 releases. So this is in like 6 months. This is what came in. And I talk about this already. We have some interesting particle packs on the store also. There are some Popcorn FX is again a company like Algorithmics who is doing both film VFX and game VFX, and it's the same algorithm behind. Audio, we don't have time. It's almost done. Yeah, I think we finish it here because we don't have much time, and I really wanted to show you. Oh yeah, okay. Sequence. Can I?
There's beer and there's Matthew. What do you prefer?
Oh.
The beer's here anyway. You can take it home with you.
Oh, we
All
can
right.
take beers and Mathieu, no? We can. Okay, I just want to show the sequencer. I have to show you the sequencer. So it's gonna be, sorry? Particle system. Oh, I have to come back maybe later on. So I go to Abai Fest like in a few days, and I will try to make my talk enter the 3 hours. And it will be recorded, so maybe you can watch the talk, and I try to talk about particle systems, and also you can rewatch what I've done. But I really want to show the sequencer because it's really, really cool. And if you can wait 5 minutes for the beers. So.
Okay, we found a good solution. Okay, you guys are going to get beer and juices while you listen to Matthew.
Oh, wow. Thanks. Can I do the same also? Yeah. That's one of my favorite things is to drink a beer during a talk. I really love that. You feel like at home. So our sequencer, I will show you some slides still because sometimes it explains faster. Okay. Okay. Yeah. So there is a workshop just after that of 3 hours with me if you want to. No. So I don't go to the finished thing, sorry. I will. Okay, I just make a small break because this is nice. So this is a vision of how this is how film and games were working together until now, I think. And okay, so I really hope that we do the same. You know, it's like we don't know where we're going, but it's cool. I just wanted to show you that. And so these are cinematic sequences. And where is our sequencer? Okay, it's here. So our sequencer, it's very important because that's where everything that we've seen before are getting together in this. Once you have understood what I've said before, you just have to put this on the sequencer and you start telling a story. So we released it in 5.6 in an experimental build. So it has been used in productions, in various productions right now. But if you want to start, use the 2017.1. Don't use the 5.6 because we don't maintain it. So the official one, and it's official, it will be in Unity, it will be supported. And what is interesting is that, you know, sequencers, there were slides before, but sequencers have been the heart of productions. You know, like for music, before you were cutting the tape and you were putting them together, and then suddenly with the computers you could do this on a sequencer, and that's what changed the industry of music. And then for video, same thing. You were cutting the things even longer than for music, and then suddenly on a computer you could start assembling, and again it's called a sequencer. And then when you think about game engine and all this revolution, we needed a sequencer, but each time, like the video added video on top of audio sequencing. Here in a game engine, you need to be able to sequence gameplay. You need to be able to sequence things happening at real time. You need to be able to sequence animation. And this is tricky because there were not so many sequencers. I mean, there were some in Motion Builder, there were some Matinee in Unreal. But the thing is, like, once you start developing a tool, you're afraid that something is missing to somebody. You know, it's like, oh, I wanted to make a sequence, a clip, which is, I don't know, following with a light, which is automatically following at the right place the character. I wanted a clip which activates a sequence, a dialogue. You know, I wanted a clip that makes an overlay with a text. I wanted a clip that makes a blur between two frames. But because you can do this in multiple ways on a game engine, what do you do when you do a sequencer? So what we did is that we did a generic sequencer. So we provide an animation track. You drag and drop animation and they play automatically. We have an audio track. You drag and drop an audio clip. It plays audio. We have an activation track. You can activate and deactivate object. But then you can create your own clips and your own tracks. Like we have an API, and you explain what happens when you enter for the first time the clip, what happens while you're playing, what happens when you exit, what happens when you blend two events. And then you can do whatever you want. If you want to do the fading of a fade to black, you just implement something which draws a quad on top of the scene, maybe which also deactivate everything because you don't need it. And then when you merge two of them with a second one which is transparent, it's going to automatically fade to black because you just write a script. So with a few lines of script, you can have completely custom components. Oh, thanks. For the people who already have a beer, I'm the first one. Okay, I wait that everybody has a beer. So to do this, it took us 3 years and throwing an entire project to the trash. So 3 years ago, we made Blacksmith, which was our previous short, and we realized that we didn't have the right design. Like we couldn't customize, we couldn't generalize this. So how is our timeline working? Where is it? How is our timeline working? Okay, here. So what it is like, this is just UI, but the backend is actually a graph. You know, when you do this, you're actually evaluating a graph. And for the software developer who are here, what is interesting is like, this is totally generic. You know, when you start evaluating a graph, mixing two things is just missing two parts of the graph together. And what is interesting is like, since this is a graph, you can actually take a timeline and put it in any node of the graph. So you can put a sequence into another sequence, you know? So imagine, so this is actually not available right now, but we designed it for that, so that you have a shot, like this is like, the first moment is a sequence, and then you take this sequence on another sequence, which is a master sequence, and you will have this as if it was a movie clip, you know, but actually it's the things happening. And you can even blend two sequences which are a series of things. I will show you an example, a real example of how we used it to customize, because maybe it's a bit abstract for you. So this is our API. This is to make a camera switch. So you just specify which camera you want. This is a custom clip. This is all the code that you have to write to make a custom clip which switch a camera to another one. It's just like, basically it's one line of code. When you enter this clip, you will just enable the camera if you're playing it. If you're not playing this clip, you just disable the camera and you make a camera switcher, you know? This is one line of code. And we also have an API so that you can create by script all your track and your clips. So for example, performance capture, you film a camera with any tracker, like on Vive or Tango camera or motion capture. You will record this as an animation, and you automatically, when you press a button, it will generate a new track on the timeline and put it on the timeline. So it's like overdub, you know, in music, where you see your track happening at the same time. So we really wanted, this is the first official version of our timeline, and this is what we wanted to have, like having the basic functionalities, being able to customize it, being able to script it. So this is where the last thing that I will show you. It's called Cinemachine. Cinemachine is, there is a guy who worked on Frostbite cameras for the Frostbite engine. So the camera for Need for Speed and so on. So when you have a racing game and you want to do the replay, you need the cinematic camera, but it has to look cinematic, but it's based on what the player did. So how do you do this? You know, like you need to have a smart cameraman. So the guy who made this has worked in Previs before. He created an asset for the asset store to have smart cameras, and now he's working with us since a year. And when on 2017, you have a package where you can play with smart cameras, and I show you what it is. So, and it will be exactly the time to drink the beer.
Because everyone's started drinking it.
Oh, really? Yeah. Okay, so I will cheer. Okay, so while I'm loading this. Okay. So, cheers. Cheers. Thanks a lot for the welcoming event and people. That was very nice. So, okay. So, last demonstration. Yeah, maybe we can turn it off again because it's. I can cheers by daytime again. Cheers. Wow, there's so many people. I'm very happy. So, where it is? It's here. So, this is something I've just taken the asset from the blacksmith demo. They're also available. Each time we do a demo, we try to release the assets. So I took the assets from the blacksmith demo, and I recreated a bit of the sequence. But you know, I'm not an animator, so I just use our standard asset animations, which is idle, which is like this, and walk, and it's just a walking cycle, right? So what I did here, you see, you can go through the timeline, and I have the generic animation, which is idle. You know, it's idling. We see it idling a bit. And then you have walk. Then I repeat walk. I repeat walk, 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 I repeat walk. And then I go to idle again. 2 animations for this. You see it's idling. And then you see here that I deactivate the characters that I had before. And I activate a new character which has a generic rig because I wanted exactly the motion capture animation. So here I have the motion capture animation playing. And now I reactivate the other guys. If we turn around, we will see it. We should see the 2 of them. You see? I have activated the second one, so he's here on the back. And then he's working outdoor. So I'm not a cameraman neither, and it's horrible to make camera keyframing. So what I did is I will show you actually here. Let's go. Let's go. Let's use the mouse. You can be sure that it's gonna crash or that I will fuck on the last demo. But anyway, so okay. So you can lock it here if you don't want it to go away. So how do I do? I have this animation here, which is walk. Okay, I'll duplicate it here. And now if I play it here, you can see my guy who is walking. Okay. If I want him to walk longer, he can walk longer. So I will make him stop. Let's say here. So here. No, I will take the. So I have a bunch of animations here that are just like generic animations that I reuse on any character. So I take my idle. Okay, here. So we go from walk to idle, but the idle is not at the right place. No problem. You right click, and you match the offset with the previous click. Now it's running the animation exactly where it stopped during the last one. But the problem is here. If we look, it will go very sharply from one animation to another one. You see, it's like, bam. It's not very natural. So for this, because we have a generic animation system, you just blend the 2 of them, and it will blend the 2 animations. You see, oops. So it moves a bit back here. So let's make it a bit subtle. Okay. So when you go from the top and you see him, it's like you don't see the. You see it a bit. Let's match again. Yeah. So now let's go to the camera work. So I want a camera that is, let's say, here, but is walking. So oh no, I have to keyframe the entire stuff. Oh, I don't like this. So what I do is we have this cine machine, which is this custom clip. So on the camera, actually I have to activate this camera up. So on the camera, I have a cine machine brain, so which is a brain for all the virtual cameras, like a director, right? And this cine machine brain, each time I will put a new clip here, this one, this will be a virtual camera. So I create this virtual camera, which is here. I will place it. So let's say I like this position, so I'm here, and now I have this virtual camera. Okay, that's okay. But now I want to follow the guy. Okay, so let's say I want to look at his eye. So I will say I want to look at his eyes. Now it's moving with the camera, right? Because it's following the eyes. But I don't like the composition. If I would be a director, I wouldn't like this kind of composition. I want something which is more cinematic. I want a frame like 1/3, 1/3. So what do? I say, I don't want a hard constraint. I want a composer. I want this to be at 1 frame and keeping this very nice, interesting thing. So now it's keeping the frame. You see? It's like you're a director. You say what the cameraman is supposed to do, and it's keeping this. If I want to do a second clip, I will just add another one. Okay, create a second camera. I will put it, let's say, here. Okay. Let's say here. Okay, if we go there, we will switch to the next camera. If I blend the two of them, it will go there and interpolate between the two of them. So if I decide to move the character or move anything, it will keep the same production. And this is the power of having like anything you want on a clip, that you can have. It's not like stupid clips. It's smart objects that you can really put on the sequence. And you can manage your gameplay, you can manage your dialogues, you can manage your cameras, you can manage your lights in a much more smarter way than before. Yeah. So that, and one last thing is here. So I want a post effect per camera. So if I choose this one here, which one is it? Okay. Okay, this one. So I will add a post-processing behavior. Oops, no, sorry, I added remove component. I told you that I would fail in the end. No. No! No! Okay, I think it's going to be time for a beer. Please. Sorry. Remove component, I will go to the end. Remove component, sorry. If I had a cinemachine postfix, I can actually create my own postfix. So they are here. So for example, there is a camera with a depth of field. So because I want this kind of mood. So I just put it here, and I will say this camera is here. So there is a big depth of field, right? And what is hard with the cameraman is to keep the target, when you have a very narrow depth of field, to keep the target on this. Here it's easy. You just say focus on the target, and it will keep the depth of field all along the way with the right stuff. You know? And yeah, that's it. So that's the sequencer that I really wanted to talk about and try it. Yeah. Thanks a lot.
That was really enlightening, Matthew. I'd like to now call Neha Singhal Mehta, the head of the editorial response team and communication solutions, to hand over a memento from Animation Express to. Please go ahead. Neha,
Thanks.
to do it. To Matthew.
Wow. Thanks a lot. Thanks a lot.
And Neha has worked very hard with the team to get this together. And a big thank you to the events team at IndianTelevision.com and also the people who worked on it. Thank you very much, all of you. And thank you to Shruti and to Quinton.
Thanks a lot for staying this long. Thanks a lot.
And most of all, thank you to each one of you all for being here. Questions?
Yes, of course, questions.
Yeah, and please serve the snacks too to them while they're at it, because this is a good time to engage and interact.
Yeah, there is a question here in the middle. Now I have a beer, I can stay as long as the place is open.
I wanted to know what all can you add to the sequencer, as in apart from the camera, what are the game objects that you can add here and animate at the
So-
same time along with the camera?
Yeah. So for example, I wanted to show you, but didn't have time. I did a small shot, and I wanted to have parts which are interactive. So it's a shot. There is a teddy bear, which is on top of a mountain, and he goes to the bottom, to the cliff, and he jumps, and then he arrives and lands on the ground, and it's a kind of music video. And I wanted that during the jump, you can actually take control over the character. So what I did is just like I created my own clip, which is just activating a component, and each time I drag and drop it, it activates my it enables on the camera one component which is a free camera and deactivate the automatic camera, you know. And yeah, I could have done something like, for example, for when you do lighting, you usually have a lighting rig, you know, like you have the field light, the key light. You could actually make a smart lighting rig, you know, because sometimes in a sequence, you just keep moving your lighting rig until the guy is moving. You can make exactly like you make smart cameras, you can make a smart lighting rig. We made also on my small short, all the generic, like all the titles, I made my own clip where I put text directly on the clip, and it will display it as a UI. And what is great is that if I want this to be a 3D image, I just change my clip, the implementation of my clip, and suddenly it's like 3D fonts or whatever, you know. Like you, what is great is really you create your own custom stuff. And if you want that in only one, like sometimes you have the fade to black, like the background, and then you have the text, you know. But sometimes you exactly know that you want the two of them together, so you just create one clip which has a public component which is what is the text, and another one which is what is the background color, and it will automatically do this. You know, you create, when you're in production, you create your vertical slice, you look at how people are producing, and then you say, oh, maybe I can make a clip which makes like 4 tracks at once, because they always do the same stuff. And this is super, super, super powerful, because yeah, and you can, I didn't show you also, you can of course keyframe directly in timeline. So you press the record button and you can add keyframes. Then if you double click on this, it opens the animation window, and it synchronizes the timeline on the animation window is synchronized with the one on the big timeline, so that you have a very good animation tool. Sometimes in sequences, you have a keyframing tool, which is different from the classic animation, and it's a bit frustrating because you didn't want to redo the same stuff, and it's not exactly the same use case. But here you have the two synchronized together, for example.
Okay, before the next question, whoever wants to grab a snack, it's at the side. In the meanwhile, the questions can go on. Because we've got to wrap up this place by about 6 o'clock, so we'd like you to eat, drink, and also have made merry.
Other questions? You can make a dialogue system also this way. You could have things which automatically focus the camera on one character and display what he's talking about. Maybe automatically play a sound. You know, it's a dialogue system in one drop, for example, like this kind of stuff. Don't state questions. Any question is welcome.
Yeah. Any other questions at the back?
People want snacks. No.
Any questions in the front? Any questions in the middle?
On the top?
Any questions from top? Any questions from down?
Okay. Yeah.
In 2017.1 version, you said the animation tool that's built into Unity is going to be revamped. It's going to be a lot different from how it was.
No, it's just like we have a new workflow. So, for example, you can right click. Before you had to record and change a value so that it creates a key, for example.
Yes.
Now you can right click on anything and say add key, and it will add a key. We have some keyboard shortcuts.
So right click on any component on the inspector and say...
Yeah.
Oh, okay.
And you can also, you have shortcuts so that you can automatically add keys. We have these scaling tools where you can select whatever keys, and you can scale them horizontally, vertically, if it's in amplitude or time. And you can even have a ripple mode. When you scale it in time, it pushes everything on the side, so that you can slow down the movement. You have very good control over this. Okay. What we are missing now is the scaling of the tangents. This is something that we don't have. But this is probably one of the last features that we really need. Yeah.
All right, are there any other questions? No? a big thank you to Matthew. And Matthew, you got to eat something too.
Yeah, thanks a lot.
And grab yourself beers and have, chat with each other, network. I hope all of you have dropped your cards or your contacts so that we can keep in touch with you on behalf of Unity.
Oh yeah, maybe I will write my email if you want to.
Please drop your cards if you haven't done it so far and your contacts.